Hello, everyone, and welcome to Apologetics 101. I'm your host, Brian. Thank you for watching and tuning into the channel. And today we are going to be interviewing Dr. Peter Line. We were going to do a live interview, and we tried to do that live, but unfortunately, even before it went live, my internet went super unstable, and we could barely even talk to each other. We had to talk to each other through the private chat in the StreamYard because it was so bad. So this is why I normally don't do live interviews. Um, uh, Something I can do every now and then, but there was too much going on. He was wanting to do a presentation. He had a really big presentation planned up and that sort of thing. So we decided to do it via Zoom. He was able to do his presentation. I was able to ask him some very good questions and following it. And it's kind of a long video, so without further ado, let's go ahead and dive into that. Thank y'all for understanding. Sorry I couldn't do this live. I wanted to do this live, but we managed to pull it off with Zoom, so it still worked out at the end. So without further ado, let's dive in.
Hello, my gentle and, of course, very modern apes.
Sure, I'd like to kiss you goodbye.
All right, but you're so ugly.
Human beings are not just related to apes, but actually aren't.
This is a primate, and so is this, and so is this, and so is this. Hey, that's me.
We are still hominids. We're still primates, mammals, tetrapod.
Hello, everyone, and welcome to Apologetics 101. I'm here today discussing human origins. We're going to be discussing probably a wide variety of things, but it's going to be touching on things like Neanderthals and Homo erectus and things like that, and the morphological differences. And so we're really going to zero in on that. I know that we did a presentation with Dr. Jerry Bergman recently on my big Neanderthal video where we discuss Neanderthals, and we're going to be touching a little bit on that today as well. But I got with you today Dr. Peter Line, and he's going to be bringing a pretty, from what I understand, pretty comprehensive presentation on the subject matter of human origins. And I've got his bio right here. Peter's undergraduate majors were in biophysics and instrumental science. After this, he completed master's and PhD degrees in the area of neuroscience, focused on brain electrophysiology, and spent over a decade involved in such research. Subsequently, he worked as a university lecturer, teaching in the area of anatomy and physiology for over a decade. Peter has been interested in creation evolution issues ever since becoming a Christian, as evolution was a stumbling block to him. Believing God's word was true, he has a particular interest in the so-called hominid fossils for many years and has published several articles on the subject matter. And today we are going to be discussing a lot on the hominid fossil record as well and discussing that. And like I said, Dr. Line, you have a pretty comprehensive presentation to present everyone, right?
Yeah, yep. Hopefully so. Do you want me to do the share screen now?
Yeah, you can go ahead and do the share screen.
Okay. Okay, so I'm going to start this talk by introducing some of the fossil species which are assigned by evolutionists that are central to the discussion of human origins, certainly that I'll be doing. Okay, so so let's start with the Neanderthals, or Homo neanderthalensis. Okay, now from their textbooks by Glenn Conroy and Herman Poncer, um, they state that the first Neanderthal ever discovered was actually from Angus Cave, Belgium, in 1829-30. They're basically a Belgian physician and anatomist, Philip Charles Schimmerling, recovered the cranial remains of at least 3 individuals who were associated with extinct animals, and one of the crania soon deteriorated and was lost to science, and another was that of a rather robust, essentially modern male dating to only about 8,000 years ago. And the third specimen turned out to be a partial cranium of a 2 to 3 year old Neanderthal child, although it was not recognized as such at the time. So that's the Angus 2 partial Neanderthal child's cranium, which is shown on the screen there. Okay, they estimate its cranial capacity at 1,362 cubic centimeters. Now, so they go on. The second Neanderthal ever discovered was unearthed in 1848 at Forbes Quarry, Gibraltar, during construction of military fortifications there. And like the Angus specimen, the Gibraltar cranium was not recognized as a Neanderthal until decades later. The name Neanderthal traces back to the 1856 discovery of a Neanderthal skull cap, or calotta, and some post-cranial bones from the Feldhofer cave in Neanderthal Valley, Germany. So I'll just show you some postage stamps there of the Gibraltar cranium. So here you can see the first, the skull cap of the first Neanderthal recognized as such. It wasn't the first one found, but at the time it was the first one recognized, and the one, and so is the type specimen, and so is it known as Neanderthal 1 or Feldhofer 1, and it's the holotype or type specimen of Homo neanderthalensis, and estimated cranial capacity of 1,525 cubic centimeters, allegedly dated to around 40,000 years ago. And note that when I present age dates or alleged age dates of fossil specimens, it doesn't mean that I believe that these dates are real. I believe in a young Earth. I provide these dates as information. A lot of the dates assigned by fossils to fossils by evolutionists often end up getting revised or overturned down the road. The dates are very plastic. Here's a 150-year anniversary of the discovery of the Neanderthal, or the naming of the Neanderthal skeleton or skull cap found. A stamp and the first day cover of it. Okay, so here you can see some of the using another. This is a cast of another skull, Lefaressi, another Neanderthal from a La Ferracie cave in France, discovered in 1909. So added a cranial capacity of 1,640 cubic centimeters. So these are quite. So a lot of the Neanderthals are quite large in cranial capacity, larger than the average modern human. Many of them, and you can see here some of the features on it where the red arrow points to. Is it the projecting mid face here? This region here projects out a bit. There's supposed to be a retromolar gap or a large gap behind the third molar. Maybe it doesn't look so that big in this picture, but and also a weak or absent chin as shown here. And some of the other features here that shows you removing the jaw from the thing in the same cranium. You have a pronounced sort of brow ridge, sort of double arch, so it's not a straight bar, more double arched. A large nasal cavity. It's a massive facial skeleton. A receding flatter forehead. This is all compared to anatomically modern humans. The average anatomically modern humans, I should say, as mentioned, as a projecting midface, and a long, wide, and low brain case, wider at the middle or bottom. Okay, and occipital bunning, a little bulge at the back of the occipital region here. Okay, and here you can see some of the features, and I'm just trying to get my mouse across. You can see here modern human has a long, higher brain case, a sort of a higher, more vertical forehead on average, smaller absent brow ridge, a mid face which is less projection except for the nose, which sticks out quite a bit. And again, here you can see the work this mouse. So the chin, you have a chin and a more prominent mastoid process here. Okay. All right. Now, so that's the Neanderthals. So the other species we'll be discussing, these are evolutionary classified species. So I refer to them because for purposes of recognizing what they are. Although I don't necessarily believe that they should have a separate species name. But anyhow, so you have Homo heidelbergensis. So the births. I'm kind of just discussing most of at this stage just the origin of these, or when I first discovered. That's so we'll talk more details about some of the stuff later. So the holotype specimen, that is the original type specimens, whose description of the species is based for Homo heidelbergensis, which is also known as Heidelberg man. It's the molar mandible or lower jaw. I'll show you that in a second, which was accidentally discovered by a workman in 1907 in a sand and gravel pit at Moa, about 6 miles southeast of Heidelberg, Germany. On the Moa jaw, Chris Stringer and Andrews write that the teeth were clearly human in number and shape, but the jaw was very thick and it completely lacked a chin at the front. They further stated, as was common in those days, it was assigned to a completely new species, Homo heidelbergensis, Heidelberg man, but few scientists took this name seriously. As the century proceeded, it came to be regarded as probably representing a European form of Homo erectus. So there's the molar mandible here. There's just a holotype of Homo heidelbergensis discovered in 1907, allegedly dated about 609,000 years ago. Okay. Now, the taxonomic allocation, that is the classification of the molar mandible, was initially to Homo heidelbergensis in 1908 and is currently to Homo heidelbergensis, but has also included Homo erectus, Homo neanderthalensis, that is the Neanderthals, and inserta sedis, the classification means difficult to assign to any taxon. And as mentioned, supposedly dated to an age of 609,000 years ago. It was not until approaching the end of the 20th century that more serious interest in the name Homo heidelbergensis occurred. The taxonomic confusion over the molar jaw parallels the taxonomic confusion over Homo heidelbergensis, the species it is currently allocated in. That no cranium is found with the molar mandible, but has not helped the situation. In the words of Paul Jordan, writing in 1999 in his book, The Neanderthal, the jaw today goes by both the names of Moira and Heidelberg, and by virtue of primacy of scientific naming, Homo heidelbergensis is the name that many scholars give to the whole stage of human evolution that comes between Homo erectus and the various representatives of early Homo sapiens, whether on the way to fully modern or Neanderthal forms that have been found in Europe, Africa, and Asia. But others are content to call Moa itself and its contemporaries in Africa and what came after them by the name of archaic Homo sapiens. It is worth noting that there can be nothing hard and fast about any of these classifications, either in view of paucity, fragmentariness, and evident variability of the specimens to hand. So here's a cranium of Homo heidelbergensis specimen, the cubby one, cranium. So that's has been affiliated with Homo heidelbergensis, but also is the holotype of Homo rhodosensis, depending on which classification is used. So a lot of these specimens, they're not just in one species, they're depending on who's classifying them, they may be classified as in another species. Like I said, there's a lot of confusion in this classification on Homo heidelbergensis. So that's from Zambia, estimated cardiac capacity 1,325 cubic centimeters, allegedly dated about 299,000 years ago. Now, some evolutionists also recognize that an excess multiplication of taxa exists in the human evolution fossil record. Speaking on a general trend today to recognize more species within the genus Homo, Cartmel and Smith stated in 2009 that fossil remains that would have been grouped together as Homo erectus 10 years ago are now sometimes partitioned among as many as 5 species, including Homo ergaster, Homo antecessor, Homo georgicus, Homo heidelbergensis, in addition to Homo erectus proper. They added, it is important to remember that there is no unanimity among scholars concerning the diagnosis, membership, or even existence of Homo heidelbergensis. A precise morphologically based definition of this taxon has yet to be offered. So it's not a very convincing species. In discussing issues in regard to the validity of archaic species in the genus Homo, including Homo antecessor, Homo rhodosensis, Homo mauritanianus, Mauritianicus, or Mauritianarchus, or however you pronounce it, Homo helmi, Homo solorensis, Homo heidelbergensis, and Homo neanderthalensis. Paleontologist Daniel Lieberman in 2011 observed, as with Homo erectus, we simply lack the knowledge to test hypotheses about taxonomy at the fine scale we would like. A sensible solution is to recognize that there were probably several lineages of archaic Homo, all variations of the same basic plan. These taxa share with Homo erectus many features such as long low vaults, vertical but projecting faces, thick cranial vaults, and marked brow ridges. They differ from Homo erectus primarily in having relatively larger brains and faces, and brow ridges that arch more over each orbit, and then lacking a few characteristic features of Homo erectus such as sagittal keels and long knuckle planes. With the exception of the Neanderthals and modern humans, both of which have suites of distinctive features, there is no obvious way to group these fossils into different species on the basis of craniofacial variations. Here's another Homo heidelbergensis skull, Boda 1 skull. So it shows a cast of it. Okay, apart from being affiliated with Homo heidelbergensis, it's also the holotype of Homo bodoensis, which was kind of a name given to not just a few years, not that long ago, actually, just a few years ago. It's from Bodo, Ethiopia, discovered in 1976, estimated cranial capacity 1,250 cubic centimeters. Has a very, very large face. Now, so on Homo bodoensis, Mirjana Roxandig et al. In 2021 proposed that the hominin taxon Homo heidelbergensis be abandoned. This is because it had been inconsistently used and poorly defined, failing to reflect the full range of hominin variability in the Middle Pleistocene. They suggested that Middle Pleistocene fossils of Homo heidelbergensis, sensu stricto, that is, in a narrow sense, from Western Europe should be reassigned to Homo neanderthalensis, that is, the Neanderthals. The authors also proposed abandoning the classification of Middle Pleistocene Asian archaic hominins, particularly Chinese ones, into Homo heidelbergensis, as they likely represent a different lineage altogether. Roxandig et al. Proposed a new Middle Pleistocene hominid species as representing direct ancestor of Homo sapiens based on a Bodo skull, hence the name Homo bodoensis. The Middle Pleistocene, that is also known as the Chibanian for some reason, is regarded as a period supposedly 129 to 774,000 years ago. Evolutionary paleoanthropologists admit that the hominin fossils assigned to this period are poorly understood. They call this problem the muddle in the middle. Others, like paleoanthropologist Chris Stringer, does not see the need for a new species name. According to Michael Marshall's writing in New Scientist, Stringer does agree that Homo heidelbergensis has been used too loosely. He says, I'm partly to blame for this wide usage of Homo of heidelbergensis. He says apologetically. He thinks it should now be confined to the original moa jawbone and some other European fossils, such as the BH1 jawbone from Mala Balanica cave in Serbia. As for the African remains, Stringer is happy to use Homo rhodosensis. He argues it was named for the country in which it was found, not for Cecil Rhodes himself, and therefore doesn't honour him. Furthermore, the rules set out by the International Commission on Zoological Nomenclature state that established names have priority. So because Homo rhodosensis has already been formally named, it should be used unless the original description was wrong. Alternatively, if Homo rhodosensis is deemed unsuitable because of its imperial connotation, Stringer says there are existing alternatives. For example, the Saldana cranium, one of the specimens Roxanne's team placed in Homo bodoensis, was dubbed Homo saldanensis by Matthew Drennan in the 1950s. Even if you got rid of rhodosensis, there are other names that would apply rather than creating new ones, says Stringer. Stringer is also skeptical of the claim that the bodocranium is a direct ancestor. In 2019, his team published a study of the evolution of the human face, which found that the species the bodocranium belonged to had gone down a different evolutionary path to our species. That's according to him. So here's another specimen, Homo antecessor, discovered in 1994 and 1995 in Grandolina, Atapuerca, Spain. It's cast of a juvenile partial cranium. So it's affiliated to Homo antecessor, dated to about 800, allegedly dated 850,000 years ago, around them, and suggested cranial capacity is 1,220 cubic centimeters. That'd be a very rough estimate, given the incompleteness of the specimen. Now, according to Lewis Humphrey and Chris Stringer, writing in the book Our Human Story, even more controversially, it's been suggested that Homo antecessor could have been the last common ancestor of the subsequent Neanderthal and Homo sapiens lineages, with the flat face and hollow cheekbones of several individuals presaging the morphology found in modern humans. The last idea has been challenged because Homo antecessor seemed to be too ancient to represent the last common ancestor, which was believed to have lived only about 500,000 years ago. But recent research discussed below suggests that the last common ancestor of Neanderthals and modern humans may have lived well before 500,000 years ago. And additionally, microscopic study of the face in Homo antecessor does indicate a resemblance to a modern pattern of growth, giving rise to a flattened face and delicate cheekbones. Right. So for as long as the fossil specimens are interpreted using an incorrect model evolution, the muddle in the middle will remain in a confused state, as will be the identity of the last common ancestor of Homo sapiens and Neanderthals or any other human species. Whether they are called Homo heidelbergensis, Neanderthals, archaic Homo sapiens, Homo bodoensis, Homo antecessor, Homo rhodosensis, or some other name, the fossil specimens assigned to these categories do not represent evolutionary ape-man stages between Homo erectus and modern Homo sapiens. Rather, they were fully human descendants of Adam and Eve, as were the fossil specimens assigned to Homo erectus. So that's a reasonable decent look at Homo heidelbergensis. Let's go on to another one, the Denisovans. A research team led by Swante Pabo, after extracting genetic material from the finger bone, classified as Denisova-3, sequenced its mitochondrial DNA in 2010. The mitochondrial analysis of the finger bone, which is a proximal fragment of a distal phalanx, said to be from a layer dated between 48 and 30,000 years ago, found that Neanderthals and Denisovans differed from modern humans at an average of 200 have found that Neanderthals and Denisovans differ from modern humans at an average of 202 and 385 nucleotide positions, respectively. From this, it was concluded that an extinct species of human ancestor had existed in Asia about 40,000 years ago, and also the first time a hominin has, I say a hominin has been described not from the morphology of its fossil bones, but from the sequence of its DNA. So these are finger bones here, the proximal end of a distal phalanx. Not much. So discovered in 2008 in the Altai Mountains of southern Siberia. Okay. All right. So what did the Denisovans look like? A scrap of finger bone and 3 teeth, which was known about up until the start of 2009. I don't tell you next to nothing about what the Denisovans looked like. However, in early 2019, it was announced that a palm-sized section of a brain cavity was the first Denisovan skull fossil ever found. Discovered in Denisova cave in 2016, the parietal bone fragment known as Denisova 13 was attributed to being Denisovan based on its mitochondrial DNA and consists of 2 adjoining posterior half fragments of the left parietal. Now, it's described by Bruce Bauer in the reference on the top of the screen there. Quoting him, he says, Viola of the University of Toronto and his colleagues compared a digital reconstruction of the skull fragment with corresponding parts of 112 present-day human skull and 30 Stone Age Homo skulls, including Homo sapiens and Neanderthals. The Denisovan find didn't fit neatly into any previous known Homo species. Some features linked the Denisovan fossil to Neanderthals and to a 430,000-year-old Spanish Homo species that had Denisovan ancestry. The Denisovan skull fragment is supposing thick, more like cranial bone of Stone Age Homo erectus, Viola said. In May 2019, Chenadal reported on a Denisovan mandible of the right half, referred to as the Zia mandible, that had originally been found by a monk in 1980 at an altitude of 3,280 meters on a Tibetan plateau in Bashia Karst Cave, Xia County, China. I hope I pronounced that right. The Zia mandible was identified as Denisovan by ancient protein analysis and said to be dated to at least 160,000 years ago through uranium series dating of carbonate matrix adhering to the mandible. The mandible, which has no chin, was described by paleoanthropologist Robert Sars as the mandibular morphology in general is primitive, short and very robust and close to Homo erectus specimens, but the less elongated shape of the dental arcade is close to that of the earliest Middle Pleistocene specimens of Neanderthals and Homo sapiens. The teeth are similar to the Denisovans from Altai Mountains, and the morphology fits within Pleistocene hominin variability. So the Xia Denisovan mandible shown there, discovered in 1980, found at an altitude of 3,280 meters in the Tibetan plateau, and identified by ancient protein analysis as being Denisovan, and allegedly dated to 160,000 years ago. So continuing on with the Denisovan, so now paleoanthropologist Jean-Jacques Hublin is quoted predicting back that most of the Chinese hominin fossil record younger than 350,000 years and older than 50,000 is made of Denisovans. Now, whilst one cannot yet say with certainty that the Denisovans were Homo erectus, indications are that they were erectus-like. And whether you call them Homo erectus or Homo heidelbergensis, Middle Pleistocene hominins, that is in many ways a moot point, as there appears to be little difference between them. Now, the Denisovans are never assigned to any species name, as far as I know, until a publication 2nd November 2024. So that was about 2 weeks ago. In a paper, Christopher Bay and Ziyu Wu assigned them to a new species that they call Homo juliensis, along with some other specimens. I will come back to this later in the presentation, but you can see on the, if you look, I'll get my mouse on, moving across here, let's just see. Okay, So here you have the Denisovan fragment here. But there's some other specimen here. We'll come back to it. This is a type specimen, and this I'll discuss this more later. These are about 1800 cubic centimeters and 700 cubic centimeters estimated. Large-brained, sort of robust type humans, and this is the here, Denisovan here. So that's what we're talking about. So someone has named it in the species Homo juliensis. Now, whether that sticks or not, I don't know. Because someone names it doesn't mean others will accept it. But anyhow, we'll come back to that discussion later. But just at the moment, it is someone has put it in Homo juliensis, a new species name that I only became aware of a couple of weeks ago, and so yeah. And so the other one, one of the important ones, certainly Homo erectus. We already kind of mentioned a bit about it, but the birth of it, when its discovery. So in the late 19th century, and obsessed with the goal of finding the missing link between apes and humans, or the supposed missing link, I should say, the Dutch scientist Eugene Dubais embarked on a journey to Indonesia, then known as the Dutch East Indies. Between November 1890 and October 1892, Dubais found the fossil remains of what he adamantly regarded as being a missing link consisting of a skull cap, femur, a scrap of jawbone, and 2 teeth. And in 1895, he returned to Europe, where his missing link, named Pithecanthropus erectus, the genus name Pithecanthropus, meaning ape-like man, early suggested by Haeckel, was not greeted with the acceptance he had hoped for. Here it shows you the skull cap of the found by Eugene Dubais, called Java Man. Notice the Pithecanthropus erectus is now named Homo erectus, and it's the holotype of Homo erectus, and it's also known as the Indonesian adult Trinil 2 skull cap. So discovered in 1891, estimated cranial capacity 940 cubic centimeters, allegedly dated to about 900,000 years ago. Well, this changes a lot of the stuff in Java, whether it's the Homo erectus ones, that the dates have been all over the place, to be honest. Now, I don't accept them anyhow, but they've been redated so many times. And what date you accept depends on what dating method used and when it was done. Anyhow, we'll move on. Now, the femur of Pithecanthropus erectus, now called Homo erectus, was regarded as essentially modern, but the skull cap was viewed as archaic, leading many scientists of the time to doubt their association. One of the first responses to Dubais' monograph about his missing link, written by paleontologist Lydekker in the journal Nature, was his remark concerning the skull that appears every reason to regard it as that of a microcephalous idiot of an unusual elongated type. So this was the birth of Homo erectus, a species that has never ceased to generate debate and controversy, as it still does today. Now, there were other important finds after Dubais' Java Man, including more Neanderthal fossils and Raymond Dart's Australopithecus africanus skull, known as the Tong skull, as well as the Fraudoum Piltdown Man. But the next fossil of real impact was Peking Man from China, another Homo erectus. The skull of Peking Man was discovered in 1929, although based on a pair of teeth, the fossil had already been named in anticipation as Synanthropus pekinensis, that is Chinese man of Peking, that had been named several years earlier. The Sukadian or Peking man, a Homo erectus skull from Sukadian, China. The reconstruction is a composite of several individuals, and it's a presumed male. Now, important Homo erectus fossils were uncovered from several years at the Chukutian site near Peking, known as Beijing, but hostilities brought all fieldwork to an end in 1937. Then, around the time in the late 1941, when war broke out between Japan and the United States, the Peking Man fossils mysteriously disappeared, not to be seen again. It was in 1951 that members of Sahelanthropus and Pithecanthropus were subsumed into the one widespread species, Homo erectus. Now, there is considerable contention among evolutionists regarding the number of so-called hominin or hominid species. I used to call it hominid, but they changed it to hominin for reasons I won't go into. Now, splitters are those who favour dividing the fossil record into many taxa or groupings, while those lumpers favour the opposite, that is, consolidating these hominin fossils into fewer species. According to paleoanthropologist Susan Anton, the famous splitter versus lumper dichotomy is rife in Homo erectus, as alternative species hybridomes abound. In classifying Homo erectus, some evolutionists regard it as a widely dispersed single species exhibiting considerable variation, so you call it Homo erectus sensu, whilst others adopt a multiple species approach, which is in its simplest form distinguishes early African Homo erectus, that is fossil mostly from Cubiphora and Westocana, as Homo erectus, but leaves other African Homo erectus, for example, OH9, and the Asian fossils within Homo erectus. That's according to Susan Anton. And now others find two species too restrictive and so categorize more to the point of the ridiculous. For example, in the last human guide to 22 species of extinct humans, Soyerdale describes several species that lumpers would instead incorporate into Homo erectus sensu, including Homo georgicus, the Dmanisi specimens, Homo pekinensis, Peking man, Homo ergaster, Homo erectus, some Javanese fossils such as Singerian 17, Homo soloensis, the Javanese Nangong skulls, and Homo mojogotensis. Now, in manifest contrast to such extreme splitting, multi-regional evolutionist Milford Wolpoff includes Homo erectus in Homo sapiens, stating that one of the reasons for doing so is that no single definition has been found to distinguish Homo sapiens, defined traditionally as the descendant of Homo erectus, from Homo erectus in all regions where the fossils are found. He added that there is no distinct beginning for Homo sapiens as long as Homo erectus is recognized. Here's a cast of another adolescent skull, the Tucana boy or Neanderthal boy, known as KNM WT 15,000. So affiliated with Homo erectus is also Homo ergaster. It's from West Tucana, Kenya, discovered in 1984. Estimated cranium capacity at 1,880 cubic centimeters at time of death. May have grown a little bit, not much, a little bit larger if it gone to adult, and allegedly dated about 1.3 million years ago. I show you pictures of skulls and that. It kind of breaks up the talk a bit, but it also shows you it gives you an idea what the sort of things we're talking about. Now, concerning whether a fossil specimen or fossil species belongs in the genus Homo or not depends on what is meant by the genus Homo. Now, if the genus Homo is a compilation of fossil specimens that were all part of the same human kind, that is, descendants of Adam and Eve, then obviously extinct apish primates such as the Australopithecines, including many Australopithecine specimens wrongly designated as Homo habilis, are omitted. Strictly speaking, species in the genus Homo, such as Homo neanderthalensis, Homo heidelbergensis, and Homo erectus, should be reclassified as Homo sapiens, perhaps as Homo sapiens sensu if they are all part of the same human kind. However, for ease of identification, since the physical anthropology literature is saturated with the terms, it is convenient to use the names for different human fossil species when referring to them. Here, the fossils from the species Homo neanderthalensis, Homo heidelbergensis, and Homo erectus are assumed from a creationist position to be post-flood humans, hence descended from the eight survivors of Noah's flood, although remains from the pre-flood world cannot be totally ruled out, at least in my opinion. Now, this is a cast of the adult cranium OH24, nicknamed Twiggy, affiliated with Homo habilis, which I believe is just a phantom or illusory species. Most of them belongs to the Australopithecines. and this one is likely a robust Australopithecine, discovered in 1968 from Olduvai Gorge, Tanzania. Estimated cranial capacity 590 cubic centimeters, but likely inflated. Alleged dated to be around 1.8 or so million years ago. Has a dish-faced a feature of the robust Australopithecines. Now, as noted by Cartmel Smith, OH24 is a dished face, a feature of the robust Australopithecines in which the zygomatic, that is the cheekbones, jut forward on either side beyond the nasal region from their brief analysis. It seems OH24 may have had more in common with the robust Australopithecines than the gracile types. However, OH24 turned out to have a dished face. This awkward fact bolstered the contention of some that Homo habilis was not clearly separable from Australopithecus. Nevertheless, OH24 differs from any earlier Australopithecus in several respects. It has a more distinctly defined supraorbital torus, that is the brow ridge, and a deeper mandibular fossa. In basal view, it shows signs of a more flexed basic cranium with a more central foramen magnum. That's the hole where the spinal cord goes through, and a short anterior cranial base than earlier gracile types of Australopithecus. Of course, the same thing can be said of some robust Australopithecus crania. So from a creation position, differences in morphological features between, for example, Homo erectus and Homo sapiens are not interpreted as either due to retention of primitive characteristics in Homo erectus from supposedly earlier Australopithecine hominins, or as novel evolutionary adaptations in Homo sapiens. Rather, differences in morphological features are considered as variations within the humankind, Homo sapiens sensulato, if you like, whether caused by genetic or environmental factors, and whether considered normal or pathological, that have nothing to do with human evolution. The challenge then becomes to explain why some of the observed features in the above-mentioned fossil species, like Homo erectus and Neanderthals, are not commonly observed in anatomically modern humans. Okay. Fossils of Homo erectus sensulato remains to be discovered in the land masses of Africa and Eurasia. They appear to have be concentrated in including Java, this is the central island of Indonesia, China, East Africa, Kenya, Tanzania, Eritrea, Ethiopia, and Georgia. Remains have also been found in Morocco, North Africa, Saleh 1, and India, Narmada. Although some of them, like Narmada, they may classify it in some other Homo heidelbergensis or some other scheme. Homo erectus remains have also been found in Denizli, Turkey, the partial cockabus skull cap, and South Africa, DNH 134. Ronald Clark has suggested the partial cranium SK47 from Swartcone, South Africa, should be classified as an early Homo erectus. He's also suggested that Soprano 1 cranium belongs to Homo erectus, which will also place the species in Italy. So here's a cast of the cranium Soprano 1, affiliated with Homo heidelbergensis, Homo erectus, Homo sapronensis, Homo antices. So it's kind of been, affiliated with all these things. Discovered in 1994, estimated cranial capacity has varied from 1,057 to 220 cubic centimeters. Initially dated to allege about 800,000 years ago, but later dated about 353,000 years ago. This shows you how plastic some of these dates are, how some of these species names are, and even the estimates of cranial capacity are. Now, according to Susan Anton, Homo erectus is essentially a cranially defined species, and that, depending in part on the sample being considered, workers' definitions vary. According to Milker-Wolfoff, in our analysis of this in 1994, in our analysis of the features distinguishing Homo erectus from Homo sapiens, we were able to identify only a few Homo erectus characters that we can conclude are also not shared by Homo sapiens. Now, of the above features, only the femoral pilastra and pilastric index are not related to the skull. Okay, so they're kind of related to the femur, the bones, the postcranial skeleton. So here you have what they found was you have anterior projecting supraorbital tori, thickening of the cranial wall of both cortices and diplo bone, strong annulation between occipital and knuckle plane, dominance of the sagittal length of knuckle plane over occipital plane length, and coincidence of Indian bump on the back and opistocranian, um, which is the most posterior point in the back of the skull. So if you go back here, so if I go here, let's see, here you can see here's the you can see the strong angulation in the occipital region between the occipital and knuckle plane here, and how the knuckle plane in this one seems to dominate the sagittal length here. And also you can see the projecting supraorbital torus here in this specimen here. So certainly has this specimen certainly has Homo erectus features. Anyhow, now these multi-regional evolutionists who merged Homo erectus into Homo sapiens said they restricted their Homo sapiens sample to the last 30,000 years, a period during which they stated it is universally accepted that the only humans are unquestionably modern Homo sapiens, and also wrote that of the above-mentioned characters, some actually are present in recent Homo sapiens, albeit rarely, and many are common in earlier or so-called archaic Homo sapiens. In regard to the so-called archaic Homo sapiens, these specimens have mostly been assigned to Homo heidelbergensis, although some finds are now labeled as archaic humans. Here's another cranium known as Homo erectus, KNMR 373. So it's from Kubifora, Kenya, discovered in 1975. Estimated cranial capacity about 848 cubic centimeters, allegedly dated about 1.78 million years ago. Okay, but most textbooks include a much larger range of cranial features separating Homo erectus from Homo sapiens than identified above by Wolpoff et al., as mentioned in the previous slide. One reason for this may have to do with what specimens are considered Homo sapiens. Another factor may be the frequency at which a morphological character must be seen in Homo sapiens before it is considered common enough to be included as a feature present in Homo sapiens. For example, Conroy notes as a distinguishing feature a lack of chin in Homo erectus, a distinguishing trait not included by Wolpoff et al. Is this because the latter considered it frequent enough in Homo sapiens not to warrant such a claim? I don't know. I don't know the particular reason, but difference in which specimens are categorized as Homo erectus may also be a factor. Okay. So on the right is a cast of a Sagerian 17, which is Homo erectus cranium from Java, Indonesia, one of the most intact fossil skulls from Java, has a cranial capacity of about 1,000 cubic centimeters and allegedly dated about 1.3 million years ago. On the left is a cast of the Bodo Homo heidelbergensis cranium. I think I showed that earlier, from Ethiopia, which has one of the most massive faces of all human fossil skulls, and cranial capacity about 1,250 cubic centimeters, alleged date about 0.6 million years ago. Now, a related issue involves differences between skulls of specimens belonging to the broader definition of the groups Homo heidelbergensis, Neanderthals, and Homo erectus. When you cast of fossil skulls specimen assigned to Homo heidelbergensis, it's not obvious what exactly differentiates them from Homo erectus apart from the larger size of them. Are we dealing with different species or just different size specimens of the same species? Perhaps some of them are subject to different environmental influences and or genetic drift, and perhaps subsequent inbreeding also played a role, that is making some features more prominent by being homozygous, that is having two identical alleles of a particular gene or genes. Was there any pathology? What role, if any, did epigenetics play? Did the modification of gene expression rather than alteration of the genetic code itself? As indicated by the late evolutionary anthropologist Harry Shapiro, who was chairman emeritus of the Department of Anthropology at the American Museum of Natural History, some of the differences between Homo erectus, Homo heidelbergensis, and Neanderthals may have been size-related. Quoting him, he says, but when one examines a classic Neanderthal skull, of which there are now a large number, one cannot escape the conviction that its fundamental anatomical formation is an enlarged and developed version of the Homo erectus skull. As in Homo erectus, it has the bun-shaped protrusion in the occiput, the heavy brow ridge, the relatively flattened crown that from the rear presents a profile like a gamma relief. Its graded breadth is low, just above the ears, and the absence of a jutting chin is typical. Here's another cast. This is a cast of, I think I also showed the skull earlier, the Lathrasian skull, affiliated with Homo neanderthalensis, discovered in 1909, cardiac capacity estimated at 1640 cubic centimeters, alleged date is about 68 to 74,000 years ago. All right. Now, evolutionists cite changes in the form of the brain case, for example, increase in parietal breadth, broadening of the frontal bone behind the eye sockets and at the coronal suture, increase in the height of the brain case, and expansion of the occipital plane of the occipital bone with respect to the knuckle plane as simply byproducts of the expansion of the cerebral cortex relative to the brainstem, which causes the upper part of the brain case to get bigger relative to the rest of the skull. According to the craniofacial development experts, Jeffrey Sperber et al., the adult form of the neurocranium, that is the brain case, is the end result of the preferential direction of the forces set up by growth of the brain constrained by these dural fiber system that is connected tissue covering the brain. Without the dural bands, the brain will expand as a perfect sphere because the dura mater serves as the endocranial periosteum. It also determines the shape of the calvarial bone. The periosteum is the vascular tissue that basically enveloping the bones, except at the surfaces of the joints. Now, likely some of the difference in the crania between Homo erectus, Homo heidelbergensis, and Neanderthals may simply be due to difference in brain size and a relatively minor difference in brain growth rate, as brain growth largely determines the size and form of the neurocranium, and environmental influence along with genetic drift. And you can most likely account for most of the differences between these early post-flood humans. Further illustrating the point regarding the similarity of some of these humans is that in some instances the same specimen may be classified as belonging to different species depending on the paleoanthropologist. For example, the Juniusan skull from China, dated by, shown on the left there, I only got this diagram to show, not a cast photo of a cast or anything. This skull, Juniusan skull from China, dated by evolutionists to about 280,000 years ago, has a cranial capacity of about 1,390 cubic centimeters, and is tentatively assigned to late Homo erectus by some, for example, Richard Klein in 2009. But a group of Homo heidelbergensis by others like in Tattersall, as documented by Carpenter and Smith, after analyzing the, I forgot to put capital letters in there, that's anyhow. After analyzing the postcranial, jotting that down. After analyzing the postcranial remains of Juniusan specimen, researchers inferred that Juniusan represents a cold-adapted population with an overall body form much like that of the similarly adapted European Neanderthals. Also, the Zhejiang crania, dated to allegedly 105 to 125,000 years ago from Linjing, Zhejiang, China, with a cranial capacity of one cranium in Zhejiang one is estimated at 1,800 cubic centimeters, way above the modern mean average of about 345 cubic centimeters, and exhibits Homo erectus features such as prominent supraorbital torus, that is brow ridge, a knuckle torus, which is kind of sort of a ridge at the back of the skull, although it's described as small, but low vaultide, and the widest point of the cranium being low. And they're called late Pleistocene archaic human crania by the authors. According to Anne Gibbons, writing in Science, nor are the new fossils late occurring representatives of other archaic humans such as Homo erectus or Homo heidelbergensis two species that were ancestral to Neanderthals and modern humans. The skulls are too lightly built and their brains are too big, according to the paper. In a brief article, Givens discusses the possibility that the crania belonged to mystery species, the Denisovans, known mostly from DNA. That could well turn out to be true, and it may also turn out that the Denisovans included specimens assigned to Homo erectus. Why is the Suzhang 1 cranium excluded from Homo erectus? Thickness of a cranial wall is arguably indicated by the thickness at the parietal eminence which is a prominent central area on the external surface of the parietal bone where the convexity is at maximum. And this measurement in Suzhang 1 was 7.9 millimeters. It's still within the lower range of Homo erectus, which 7.5 millimeters as measured by Kennedy back in 1991. So being lightly built would involve thin cranial wall bones, and this feature is within the Homo erectus range, along with the other erectus-like features indicated that it is essentially only large brain size that rules out the Suzhang 1 cranium from being assigned to Homo erectus. Perhaps the data as well, I don't know. According to paleoanthropologist Robert Suarez, the Suzhang skulls were initially considered Homo erectus. If crania rule out from belonging to Homo erectus simply because of a large cranial capacity, and this is just one example, then you will end up with a species of only small brain individuals, but this leads to circular reasoning. The faulty logic produces this circular reasoning. Crania are ruled out from belonging to Homo erectus if they have large cranial capacities. And then evolutionists use this as a proof that there are no Homo erectus crania with large cranial capacities. Go figure. Here's another cranium, Homo heidelbergensis cranium, known as a Petrolona cranium. Shows a cast of it. And it's been affiliated with various species, including Neanderthals, Homo erectus, and Homo heidelbergensis. It's currently affiliated with Homo heidelbergensis. It's from Petrolona, Greece, discovered in 1960. Estimated cranial capacity 1,230 cubic centimeters. One group dates it to about 200,000 years ago, whereas another group dates it to about 700,000 years ago. All right. Now, paleoanthropologist Daniel Lieberman, an expert on the supposed evolution of the human head, comments that, and I quote, Homo heidelbergensis and Homo neanderthalensis crania are generally Homo erectus-like, but with a slight increase in face size and relative brain size. In contrast, Homo sapiens represents a shift in craniofacial architecture with a retractive, smaller face and a more spherical wall. End of quote. Hence, whilst differences between Homo heidelbergensis Neanderthals and Homo erectus humans, I call them robust humans, when I group them together, it's easier to do, are generally minor. So the differences are generally minor. The difference between these humans and typical extant, that is existing anatomically modern humans, are greater. The skull is where the most significant difference exists between early robust post-flight humans and extant modern humans. And as the adult skull is a product of its development during autogeny, one must look at development changes to explain the differences. If brain development was slowed down or accelerated, it might have significant implications forms of the skull, on the form of the skull. Here just shows you a modern, again, a picture of a male anatomical modern.
Hey,
now, it is known that the development of the neurocranium is early on predominant over the masticatory and facial of the skull, due largely to the precocious or rapid development of the brain early on. The human face itself does not grow uniformly. So, according to Sperber et al., and I quote, the upper third of the face initially grows the most rapidly, in keeping with its neurocranial association and the precocious development of the frontal lobes of the brain. It is also the first to achieve its ultimate growth potential, ceasing to grow significantly after 12 years of age. In contrast, the middle and lower thirds grow more slowly over a prolonged period, not ceasing growth until late adolescence. Completion of the masticatory apparatus by eruption of the third molars 18 to 25 years of age, marks the cessation of growth of the lower 2/3 of the face. So the graph plots mean brain weight in kilograms of males and females on a vertical the vertical axis against age in years between birth and age 20 years in modern humans. Okay, and there's data tabulated for Decapana and Sadowski from data back in 1978, and you can see the largest increase in brain weights in both sexes are first 3 years of life, when the value quadruples over that at birth, while during the subsequent 15 years the brain weight barely quintuples over that at birth. So there's a really rapid growth in the brain early on. So that's really important in not just developing the brain, but the development of the skull, certainly the brain case. So progressive decline in brain weight begins at about 45 to 50 years of age and reaches lowest value after age 86 years, by which time the mean brain weight has decreased by about 11%, relative to maximum brain weight attained in young adults about 9 years of age. So basically, your brain shrinks a little bit as you get older. Okay, now, in addition, the extremely complicated growth pattern of the cranial base plays an important role, as indicated by Sperber et al., who noted that, and I quote, "The dependence of the juxtaposed calvaria, here it means skull cap, roof of the neurocranium, and facial skeleton upon the cranial base confirms considerable significance upon the latter's growth behavior in determining the final shape and size of the cranium, and ultimately the morphology of the entire skull, including the occlusion of the dentition," unquote. So hence, change the timing of the growth pattern of the brain, cranial base, and all the middle and lower thirds of the face. Changing this timing, the spatial relationship between different parts of the skull, leading to differences in skull morphology. Now, evolutionists have no problem incorporating changes in growth rates to explain some of the differences in skull features between modern and robust humans. For example, acceleration in the longitudinal growth of the cranial base early in development of the Neanderthals has been speculated to ultimately, because of a longer and flatter cranial base, have impacted both vault and facial shape and may have been responsible for many of the craniofacial differences between Neanderthals and modern humans. Let's see what we're up to. So here shows another Homo erectus cranium ducker, an adult cranium, affiliate of Homo erectus from the Middle Awash, Ethiopia, discovered in 1997. Estimated cranium capacity about 986 cubic centimeters, and it's allegedly dated about 1 million years ago. Now, it makes sense to start looking at the difference between robust humans, gracile modern Homo sapiens. It makes sense to start with the cranial morphology of Adam and Eve. However, we don't know what Adam and Eve looked like, nor do we know what Noah and his family looked like. If they lived for hundreds of years, then there had to be something different about them. Whether they were gracile, skeletal, morphological, or more robust, or a mixture, we simply do not know. It cannot be ruled out that at least some of the robusticity may in some ways have been linked to longevity. For example, being built sturdy could be an advantage of living hundreds of years. If you look at the created biblical kinds, there tends to be considerable variability or the potential for variability in the genomes. For example, cats and dogs. There is also considerable variability in how people look today. We are not identical, except for some twins. Hence, when God creates life, he appears to create it with a capacity for variation, for whatever reason he chooses. A fact that I cannot be ignored in a creation model of human origins is the biblical long lifespans of individuals in the pre-flood world, and also the early post-flood birth, as derived from Old Testament records. In the pre-flood world, lifespans of around 900 years appears to have been common, and even individuals born early post-flood, within a few hundred years of the flood having occurred, are recorded as having lived for hundreds of years, much greater than the 70 or so years that the individuals live today, although relatively few individuals may live over 100 years. According to creationist Carl Whelan, the extinction of human lines with more robust morphology, Neanderthal, Erectus, may correlate with extinction of longevity. The robusticity may be the result of genetic longevity, delayed maturation, or the same populations may have had possibly linked genes for longevity and robusticity. So here it shows the lifespans recorded in the Bible, beginning with the pre-flood patriarchs plotted at date of birth. Notice the pronounced drop in lifetimes following the flood. This is evidence for something very dramatic happening in world history. So how can long lifespan, by the way, of course, a proposed relationship between longevity and robusticity is speculative, as is any explanation of robusticity, but at least to me, it seems worthy of exploring. So how can long lifespans be related to robusticity? Simply put, longevity would probably be associated with changes in development, not just the aging process. Look at it from the science point of view. One reason for having thickened cranial wall bones, a heavily built face, thick bone jaws, and thick postcranial bones may have been a protective advantage of living for hundreds of years. It may be that we were originally built stronger to last longer. So sort of a catchphrase there. As robust humans lived early post-flood, they may well have had longevity genes. Not that I'm saying that all these robust humans lived longer, as in the case of Neanderthals. Many of them appear to have died early, but often from injury and not from causes associated with old age. However, regardless of whether they lived longer or not, they may have been programmed to develop robust features if they had the genes for robusticity. If there was linkage between longevity genes and robusticity genes, and the linkage was broken, then theoretically you could have robust humans with short lifespans. However, the genes or genetic mechanism responsible for longevity has since been lost or deactivated, as are some of the genetic mechanisms for robusticity. According to Carl Whelan, some post-flood humans may in fact have carried longevity genes to greater or lesser degree over many generations. These genes may have become extinct as the populations did. I suggest that Neanderthal and Homo erectus, for example, gives us evidence of genetically distinct humans existing post-flood. These no longer exist today as discrete populations, although some coding for some of their distinct bony anatomy were apparently passed on to some of today's populations. For instance, some Europeans carry Neanderthal bony ridge over the trigeminal nerve opening the jaw. Some of these lesser longevity genes may have survived in some such populations, say in the Neanderthals. Since these would, especially during the rigorous of the post-flood ice age, to be small and isolated, drift may again have played a major role in the eventual extinction of some of the Neanderthal genes coding for the unique aspects of their very human anatomy, for example, robusticity, large brain case, as well as possibly being responsible for the loss of their longevity, if indeed they had such. Admittedly, the suggested relation and robusticity is speculative, as I mentioned, but as is any explanation of the robusticity seen in ancient humans, it may well be that there is a better. It's an area that needs more research. As already mentioned, it's not just Neanderthals, but humans broadly categorized as Homo erectus and Homo heidelbergensis that also had some morphologies different from the average modern human. As Neanderthals, Homo erectus, and Homo heidelbergensis all, I refer to them as a group called robust humans. It seems logical that the genetic information for robust and glacial in humans, that is, the potential for its expression, must have been included in Noah and his family, ultimately derived from Adam and Eve. Whether Noah and his family all look similar, like, for example, something between robust and gracile humans, or were a morphologically very heterogeneous, that is, diverse bunch, it's hard to know. If one assumes that the genetic information for robust and glacial features in humans were included in Noah and his family, that is, there was the potential for its expression in their offspring, then at post-flood Babel, this could have resulted in a population, that is, one in which there was a large degree in variation in features. Here shows another Homo erectus cranium, BR UA31, which was displayed at a cast displayed at the Smithsonian Natural History Museum from the Danakil Depression, Eritrea, discovered in 1995, estimated cranial capacity about 995 cubic centimeters, allegedly dated about one. Now, so continue on. Then with a very morphological heterogeneous population at Babel, the subsequent dispersion may have led to different groups of people taking different subsets of genes for certain traits, including genes for variation in bony characters. This may involve genetic information involved in regulating the intensity and timing of endocrine production, that is, of hormones that stimulate bone growth. Conroy and Pons, 2012, in a textbook, Reconstructing Human Origins. One suggestion put forward to help explain the general overall robustness of Neanderthals is that the timing and intensity of endocrine production, for example, osteogenic hormones, may have differed between Neanderthals and anatomically modern humans. For example, the clinical condition known as precocious puberty, in which there is an early onset and elevated levels of sex steroid hormone production, produces Neanderthal-like symptoms in modern children. For example, robust and heavily muscle-limbed bones with large joint surfaces, thick cranial vault bones, large brow ridges, projecting midfaces, and limb bones with narrow medullary cavities. According to Susan Crockford, the distinctive skeletal morphology possessed by Neanderthals is almost certainly the result of a pattern of thyroxine secretion, therefore of prenatal and postnatal growth rates that differed markedly and consistently from that of modern humans. You don't get, because things she then goes on to say these Neanderthal traits may resemble superficially the pathological changes associated with congenital iron deficiency because they reflect different amounts of thyroxines available for skeletal growth at particular stages of development as compared with healthy modern humans. Now, here's another Homo erectus cranium, KNMER 42,700, taken from the Smithsonian Natural History. Okay, from skull found in Kubifora, Kenya in 2000. Estimated cranium between 721 and 744 cubic centimeters, alleged dated to about 1.55 million years ago. Continuing on, the release of thyroid hormones into the bloodstream is distinctly pulsatile in nature due to the intermittent stimulus for hormone secretion that the gland receives from the pituitary via thyrotropin or thyrotropin stimulator hormone. They're the same. Thyrotropin, known as thyroid stimulating hormone. This pulsatile pattern of thyroid hormone production is its most characteristic. Pulsatility originates high in the hormonal cascade, where electrical stimulation of receptors in the retina and central nervous system relay signals to the pineal gland. The pineal gland translates these electrical signals into a biochemical message, principally the neurohormone melatonin. Pulsatile release of pineal melatonin stimulate pulsatile secretion of thyrotropin releasing hormone from the hypothalamus. Thyrotropin releasing hormone pulses stimulate bursts of thyroid stimulating hormone from the pituitary, and thyroid stimulating hormone pulses finally stimulate of thyroid hormones from the thyroid gland. So it's a complicated sort of sequence of events there. Crockford also states that changes in the rates and timing of prenatal and postnatal development in ancestral species make possible a wide variety of size and shape difference in descendant populations. A well-known evolutionary pattern called heterochrony is without question the most common mode. Although identification of the precise biological trigger that implements such developmental change has proved elusive, hormonal involvement has long been. She goes on to say, slight mutations in the genes that regulate the release of thyroxine produce small pattern differences within species. Precision and timing and absolute amounts of thyroxine produced are critical to different tissues at different developmental and life history stages. As I proposed, even slight variations in thyroid rhythms will result in small physiological differences among individuals or thyroid rhythm phenotypes. Rhythm phenotypes is postulated as providing the essential raw material the individual variation for natural selection to act upon during speciation. An evolutionary explanation is unnecessary to explain the variation in foreign groups, if indeed there is such variation between different human groups. Here's another skull, Homo heidelbergensis skull, Atapuerca 5, basically affiliated with Homo heidelbergensis from Cima de la Hosas, Spain, discovered in 1992. Estimated cranial capacity 1,092 cubic centimeters, about 0.43 million years ago. So continuing on, the genetic characters, including genetic information, evolved in regulating the intensity and timing of endocrine production, as hormonal production, would have been included in human populations as they left barbel. Thyroxine T4 is an important thyroid hormone, and a different thyroid hormone secretion pattern and possibly different secretion pattern for other hormones, for example, growth hormones, sex hormones, may have existed in people with robust skeletal morphology, such as Homo erectus, Homo heidelbergensis, and the Neanderthals compared to anatomically modern humans. As such, it would be under some sort of genetic control. This could possibly account for the major difference in the skeletal morphology observed between anatomical modern humans and these early post-flood robust humans. Whilst the precise genetic mechanism for any such secretion pattern of thyroid hormones is unclear, there are clues. According to Cockford, while genes at other sites may modify the ultimate rhythmic pattern of thyroid hormones, output of several so-called circadian oscillator cells that reside in the suprachiasmatic nucleus of the anterior hypothalamus are likely the origin of pulsatile production. Even very slight individual variation in the efficiency of such genes, age identified so far, may have dramatic repercussion for traits downstream through their effects on secretion of the pineal gland hormone melatonin. Here's another Homo erectus skull, OH9, Olduvai hominid 9, from Olduvai Gorge, Tanzania, discovered in 1960. Estimated cranial capacity of 1,067 cubic centimeters, between 1.7 to 1.2 million years ago. Now, it has enormous brow ridges and cranial thickness at parietal eminence is about 10 millimeters. Okay. Now, I pronounce, so just discussing the previous discussion on the supraorbital torus, that is the brow ridge. A pronounced robust feature seen in some fossil specimens of Homo erectus, such as the Olduvai hominid 9 I just showed, and in some both in Homo erectus and some heidelbergensis and Neanderthal specimen, is the massive brow ridges, also known as supraorbital tori. There is no agreement by evolutionists on what function the supraorbital tori served, although several theories have been postulated, including dissipation of heavy chewing forces, reinforcement of the frontal bone, protecting the skull and eyes against blows, and a signaling effect accentuating, that is, making more noticeable, aggressive stares. Here's another Erectus skull, Dmanisi skull 1, from Dmanisi, Georgia, discovered in 1999. Estimated cranial capacity of 730 cubic centimeters, allegedly dated to about 1.77 million years ago. It has more moderate brow ridges, at least compared to Olduvai hominid 9. Now, one way that exaggerated brow ridges occur in present humans is through acromegaly. Acromegaly develops if growth hormone levels rise abnormally after epiphyseal cartilages close. As instead of the skeleton growing longer, the bones instead will become thicker, especially in the face, jaw, and hands. Acromegaly may be caused by a tumor occurring in the pituitary gland and after adolescence. And according to Guyton Hall, enlargement is especially marked in the bones of the hands and feet and in the membranous bones, including the cranial nose bosses on the forehead, supraorbital ridges, lower jawbone, and portions of the vertebra, because the growth does not cease at adolescence. Consequently, the lower jaw protrudes forward, sometimes as much as half an inch. The forehead slants forward because of excess development of supraorbital ridges. The nose increases to as much as twice normal size. The feet require size 14 or larger shoes, and the fingers become extremely thick, and so that the hands are almost twice normal size.
Now, I'm not suggesting that the enormous brow ridges seen in some robust humans are caused by a tumor occurring in the pituitary gland. However, it seems plausible that some robust humans in their development may have had a pattern of hormones release different to most extant modern humans. This could involve, for example, sex hormones, that is sex steroids, growth hormone, and thyroid hormone. Here just seeing comparing the Dmanisi cranium 2280 skull one to the hominin 9 cranium. You can see a sort of a more anterior view on the left, sort of the Dmanisi one on the top, and the OH9 on the bottom, and on the right is more lateral right view. You see the more projecting brow ridge, supraoral torus of the tora of the Aldebar hominin 9. Now, Glenn Conroy and Herman Ponset mentioned in a 2012 textbook, it is interesting to note that the cranial wall thickness at birth is apparently similar for all types of Homo, including Homo erectus, Neanderthals, and early Homo sapiens, and that most of the variance in the cranial wall thickness among these groups most probably develops during later childhood under the influence of circulating growth hormones with varying levels of exercise before skeletal maturity. Anyhow, thus perhaps genetic information controlling a certain hormone secretion pattern might have existed in people with robust skeletal morphology, such as the Neanderthals, that was different to that of extant modern humans. Hence, as the people groups migrated away from barbal variants of humans broadly classified by evolutionists as Homo erectus, Homo habilibensis, Neanderthals, and modern humans, that is, arose through a combination of genetic variation and bony characters, including genetic information involved in regulating the intensity and timing of endocrine production, as well as local environmental factors, in a similar way that other characteristics of people groups became established. As time went by, some types became dominant, likely through genetic drift, but absent or close to absent in others. Here shows a Homo neanderthals skull, La Chapelle aux Saints skull from the La Chapelle aux Saints, France, discovered in 1908. Estimated cranial capacity 1,625 cubic centimeters, allegedly dated about 50,000 years ago. Now, as discussed by Conroy and Ponce, some analysis by evolutionists, and I quote, suggest that genetic drift explains the pattern of morphological differences between modern humans and Neanderthals more accurately than does natural selection or differences in mechanical loading, unquote. There may also have been considerable inbreeding in some of these groups, which may explain some of the more extreme robust features seen in some of these robust human groups. For example, making some features more prominent by being homozygous, that is, two identical alleles of a particular gene or genes, that is, they having that two identical alleles of particular gene or genes, okay? It is also unclear if epigenetics, that is, modification of gene expression rather than alteration of genetic code itself, played any role in some of the features seen. Now, also fossil humans having a combination of supposed archaic, robust, and modern graceful features appears to be a common occurrence. For example, dragon mane, according to Sejourné et al., I hope I pronounced that right. Here we report a fossil human cranium as characterized by a combination of large cranial capacity, short face, and small. It says it's cheek, but I think that should be cheekbones, as in Homo sapiens, but also a low wall, strong brow ridges, large molars, and alveolar prognathism, as in most archaic humans. Through phylogenetic and biogeographic analysis, we argue that this fossil is the most complete representative of a distinct Middle Pleistocene lineage with a separate evolutionary history in East Asia. They go on to say, however, the brain cast is clearly archaic with a very wide supraorbital torus base and palate, and a long and low shape in lateral view with a receding frontal and evenly curved parietal contour. Nevertheless, it lacks both the angulated occipital with a strong transverse torus found in Homo erectus and Heidelbergensis,
height of rhodesiensis crania, including occipital region with a central supraortic fossa, typical of Neanderthals, and they and as stated by Nia et al. In 2000, as further stated by them, the combination of an archaic but large-brained cranial vault but Homo sapiens-like face is striking, and it's also found in the less complete Middle Pleistocene Chinese fossils of Dali and Junison, although different in details of morphology. So here shows the Harbin cranium is assigned to a new species, Homo longi, in 2021 from basic Harbin City, Heilongjiang Province, China. Dug up in 1933 and later retrieved and donated to Hebei University, China in 2018. Estimated cranial capacity of 1,420 cubic centimeters, allegedly dated to by uranium series dating to about 448,000 years ago, or a minimum age. Cranium described by G et al. As massive in size, larger than all other known archaic humans, with the suborbital torus brow as massive and continuous. Actually, I don't know if you see it. That's I got the dragon man on my water cup here. Anyhow, let's go on. Now, in their comprehensive overview of the fossil evidence, evolutionists Matt Carmel and Fred Smith found something similar, stating that in southern and northern Africa, East Asia, Australasia, and Europe, early modern populations retained few morphological characteristics that evidently derived from local archaic peoples. Okay, that's the end of quote. However, this does not suggest that more branches of species need to be added to the false evolutionary human family tree. Rather, it indicates that archaic, that is, robust humans and modern humans may have been interbreeding with each other. Such interbreeding can give rise to appearances that are sometimes blended in general character, that is, intermediate between the extremes. For example, brow ridges are less prominent than in most robust humans, that is, archaics, but more so than in most gracile humans, that is, moderns. At other times, the appearance will be mosaic, like the Harbin cranium, that is, dragon man, an individual component features characteristic of robust and gracile humans, as just discussed. Here's another cranium from China. Dali cranium has been affiliated with Homo erectus, Homo heidelbergensis, and Homo daliensis, from Dali County, Shaanxi Province, China, discovered in 1978. Estimated cranial capacity about 1,120 cubic centimeters, allegedly dated to about 270,000 years ago. So we already know from ancient DNA analysis that Neanderthalensis, Denisovans, and modern type Homo sapiens all interbred with each other. Thus, by definition, they were the same biological species, all fully human. If Homo erectus and Homo heidelbergensis were Denisovans, which is not yet fully confirmed, then this would mean that they also interbred with modern Homo sapiens. Even some evolutionists, paleoanthropologists, have said that some or all of these, that is, Homo neanderthalensis, Homo heidelbergensis, Homo erectus, Denisovans, and modern type Homo sapiens, should be classified as differing subgroups of Homo sapiens. For example, Cardinal and Smith advanced the view that all but one of the above categories should be designated as subspecies of Homo sapiens. They split up the specimens in, for example, Homo heidelbergensis by, in addition to designating them as Homo sapiens heidelbergensis, for example, Petrolona and Moa specimens, grouping others such as Homo sapiens rhodesiensis, that is the Kabwe and Boda specimens, that is, for example, Dali, Junison, and Harbin specimens, because they grouped them together in subspecies of Homo sapiens. They do not give this designation to Homo erectus, but within their category of subspecies of Homo sapiens, they do include some specimens usually regarded as Homo erectus, such as Nangdong that is Solomon, remains categorized them as Homo sapiens soloensis. In some instances, where there is, for example, a combination of robust and gracile features in individuals or a blended effect, it may be that it was subsequently, after the robust became specialized in certain morphological features, that they interbred with other groups like gracile modern humans from another later wave of migration. This interbreeding may have resulted in offspring with a mixture of robust gracile features in individuals or a blended effect in certain characters. This may explain a lot of what we are seeing in the fossil record. Hence, if, for example, Neanderthals are the same species as modern humans, categorized as a subspecies of Homo sapiens, even by some evolutionists, and interbreed or interbred with modern humans, then differences in physical characteristics are of little significance, at least in terms of their humanity. People making much out of any differences in the humps and bumps on the skull should remember that the flawed pseudoscience of phrenology, with study of the shape and size of the cranium supposedly but wrongly indicated character and mental abilities. Okay, I alluded to this early on when discussing the Denisovans. So in a paper published early in November 2024, Christopher Barr and Suji Wu added a new species, Homo durensis. So basically, where they basically most, and I quote, most recently after a detailed study of the Suajo, I hope I pronounced it right, and Sujang fossils, we have added Homo durensis to these discussions. Importantly, we have assigned an enigmatic Denisova along with the Usiha and Pengu fossils to Homo durensis based on a comparative study of the present dendrographic remains. In all likelihood, given the recent observation that the Tamnu last tooth shared traits with Denisova, this fossil should also additionally be included to Homo durensis. So we have here, so you can see here, I've discussed the Sujang crania, the Usiha mandible, the Denisovans. This is the type specimen of Homo durensis. This Namada Sam was assigned to Homo erectus. So this is another recent one that isn't assigned to anything yet. We've heard about the Hobbit before, and so this is the Homo longi. We just discovered the Harbin cranium. So you have so this is basically and the Suzhou specimen is 700 cubic centimeters is in the cranial volume. So basically you have this is dated to supposedly 200,000 to 160,000 years ago. So you have these people with large brains supposedly popping up very early on. It sort of defies the sort of gradual increase in brain size. Anyhow, so but those I just get my cursor back. So this kind of, so you can see there's a lot of confusing in the naming and stuff of a lot of specimen. So the last one I want to discuss is of these hominids is the Neanderthaloids hominid 50. This is an important one. Now, a problem for evolutionary theories that see Homo erectus as not fully human is that there exist fossils occurring in Australia like the Neanderthaloids hominid 50, short for LH50, that are similar in morphology to an Indonesian Nangong Homo erectus crania, but are found in a location in Australia, which, according to Bardal, for example, it's often assumed that only modern humans are capable of using watercraft and navigating to distant locations such as Australia and the Japanese archipelago. Destination that would not have been visible to the naked eye from departure points, even during glacial stages when sea levels would have been much lower. So here's a picture of Lake Mungo, part of the Land Lakes regions. So basically, in New South Wales, Australia, the WLH50 partial skull, the face, jaw, and teeth did not survive. So the partial skull, along with some hand, arm, and foot bones, were found near Lake Ganpung, which lies close to Lake Mungo there. So I visited Lake Mungo a few years ago now. Now, the age of WI50 from the Land Lakes World Heritage Area Australia is also relatively recent from an evolutionary point of view, at least to be Homo erectus, with an age said to lie between roughly 12 to 32 or so thousand years ago. With the authors of dating analysis, Grun stating, there is general agreement, and I quote, there is general agreement that WH50 is a modern human. However, some see strong resemblances between WH50 and the Nangong specimens, whilst others attribute its robusticity to a pathological source. However, detailed new studies refute the evidence for pathological hyperostosis that is excessive growth or thickening of bone tissue. So the detailed new study refuted the evidence of pathological hyperostosis of WH50. In a recent comprehensive comparison of the metric and non-metric features of WH50 with Levantine, African, and Nangdong specimens, Hawks et al. Concluded that WH50 was most closely related to the Nangdong specimens, and that its robusticity was clearly attributable to its archaic rather than its pathological nature. Their conclusion following Fawn and Wolpe of 1992 was that WH50 belonged to the same species as Nangdong and was an example of strongly endorsing the evolutionary model of regional continuity. So the above figure shows outlines of the Nangdong 1 cranium attributed to Homo erectus left from Java, Indonesia, the Neanderthals hominid WH50 in the center, and the Quavsa 9 skull from Israel on the right. And basically, WH50 is regarded as a modern human all origin model. It's a very robust skull and exhibits many Homo erectus-like features, for example, continuous massive row ridges, thick cranial wall bones, plus flat and receding forehead. It closely resembles, though, the Indonesian Nangdong Solomon Homo erectus series crania, such as Nangdong 1, shown in the outline there. However, there should not be this resemblance, though, if Solomon was derived from Homo erectus hominins that left Africa nearly 2 million years ago. If the outer Africa theory is correct, WH50 should most closely resemble early anatomically modern human crania, such as the Quavsa 9 shown on the right there, the type it is supposedly derived from, but it does not, and as reported by Wolpe et al. The above sketches were based on a photographic comparison cast by Wolpe et al. In 2001. Okay, so the old out Africa theory has been the most influential evolutionary model of human origins in the last few decades. It proposed that modern humans evolved in Africa around 200,000 years ago in the more eastern part, as indicated by the red colors in the diagram, and subsequently emerged out of Africa within the past 100,000 years or so in direction of the red arrows above, replacing that interbreeding earlier so-called archaic lineages such as Neanderthals and Homo erectus indicated by non-red colors on the map. The latter is said to be the result of earlier and more limited migrations out of Africa, the earliest nearly 2 million years ago. I don't accept, as I mentioned earlier, I don't accept the age assigned by evolutionists, but I mention it for the sake of the argument. The ancient DNA evidence indicates interbreeding between the so-called modern and archaic humans, at least with Neanderthals and the Denisovans. So hybridization is now essential to any new out-of-Africa model. But if I can interbreed, then according to the biological species concept, they are members of the same species, making them all fully human. Right. So the global multi-regional hypothesis of human evolution so basically argues that various human groups arose where they are found today. Okay, so in this view, humans, as in Homo erectus, also migrated out of Africa to different regions of the world, but much earlier, around 2 million years ago. However, rather than being replaced by subsequent recent migration, they evolved in parallel in these different geographic regions. Proponents of this theory suggest gene flow between the groups for interbreeding was sufficient to maintain humans as a single species. In this scenario, the Neanderthals and Homo erectus were ancestors to modern humans, and there was no out of Africa spread within the past 100,000 years. However, the global multi-region is no more believable than the outer Africa model. Even from an evolutionary viewpoint, it does not seem credible that for nearly 2 million years, gene exchange between small Homo erectus populations, thinly scattered across several continents, helped keep them all united as a single species, while the different populations evolved separately into the anatomical modern human form, all getting across the finish line around the same time. Recognizing flaws in the outer African model, in particular the idea that Homo sapiens evolved in a single population and a region of Africa, a consortium of 23 evolutionists put their names to a paper published in 2018 arguing for a model they named African multi-regionalism. According to Skerry et al., quote, new data suggests that a variety of transitional human groups, a mosaic of primitive and derived features, may have lived over an extensive area from Morocco to South Africa between greater than 300,000 years ago, between 300,000 years ago and 12,000 years ago. unquote. The Skiridale paper does not abandon an African origin of Homo sapiens, rather it incorporates a vague continental African version of multi-regionalism into the explanation. Kate Wong sums up their position, I quote, rather than involving a small population in a particular region of Africa, they propose our species emerged from a large population that was subdivided into smaller groups distributed across the vast African continent that were often semi-isolated for 1,000 years at a time by distance and by ecological barriers such as deserts. According to unquote, according to Christopher Barr and C.G. Wu, in the multi-regional model through gene population, Homo erectus was considered to have evolved in situ into archaic Homo sapiens, those middle Pleistocene non-Homo erectus, which eventually evolved into modern Homo sapiens. In China, this was always interpreted to mean that modern Chinese people could trace their ancestry directly back to at least Sukadin locality 1 Homo erectus, if not to the earliest appearance of hominids in China during the early Pleistocene. The other primary traditional modern human origins model, generally referred to as the out of Africa or the replacement model, posits that modern humans Africa replaced all indigenous populations with no genetic contribution to living peoples. Based on current data, it now appears that a combination of both models is a harmonious way to explain the origin of modern humans, where modern humans dispersed out of Africa in multiple ways and interacted with smaller indigenous populations regularly. In other words, modern humans across Eurasia likely arose as a result of a combination of dispersals and integration events, that is, interbreeding with each other. At the end of the unquote, at the end of the paper by Christopher Barr and Suji Wu, they write, and I quote, the Eastern Asian hominid fossil record is an excellent sample of how models of evolution such as traditional multi-regionalism cannot adequately explain the complexity in the paleoanthropological record, particularly I think the Eastern Asian record is prompting us to recognize just how complex human evolution is more generally, and really forcing us to revise and rethink our own evolution models to better match the growing fossil record, unquote. So rather than patching up untenable evolution models such as the out of Africa model and multi-regionalism, a biblical model is a much more realistic basis for further research. The evidence we do have indicates that a range of populations within people and people have always been people. Now, getting back to the Neanderthals hominid, discovered in 1980, estimated cranial capacity about 1,540 cubic centimeters, originated between 12 and 32 or so thousand years ago. From their analysis that indicates anatomical similarities, Hawks and I concluded that WH50 and other late Pleistocene fossils are modern humans, and a clear implication of their links to Nangdong is that these older Indonesian are Homo sapiens as well. The cranial vault thickness of WH50 at the parietal eminence, also referred as parietal vaults when pronounced, has been measured to be 16 millimeters, which is equal to the upper range of Homo erectus. According to Steve Webb, who originally suggested pathology in part may explain this exceptional cranial vault thickness, it is clear that WH50 is a very robust individual with or without pathology, because other heavily developed features are clearly not pathological. Besides any side pathology that might have moderately exaggerated its vault thickness, this individual would have had a thick vault in keeping with its other robust features. If WH50 had some pathology which seems doubtful, there are several other Neanderthal individuals with cranial vault thicknesses within the Homo erectus range, as well as several individuals with well-developed robust brow ridges also in the Homo erectus range. In the 2014 monograph on WH50, Wolfhoff and Sang Hee Lee stated, and I quote, we conclude that WH50 is a normal specimen without evidence of pathology or deformation, that elements of its anatomy are found throughout this fossil record as is known today. A comparisons reveal WH50 has substantial similarities to the Nangdong hominids, but not identity with them, and a demonstrable pattern of multiple ancestors that includes Nangdong as part of the network of human evolution in Australasia. This shows a Nangdong crania here associated with Homo erectus, known as sort of Nangdong, known as the Solar Man or Solar Men. Photo taken at the of the cast at Smithsonian Natural History Museum. Okay, discovered in 1932, estimated cranial capacity 1,030 cubic centimeters, allegedly dated between about 100,000 or so years ago. But a lot of these specimens depends on what dating method you use. The dates are all over the place, to be honest. Now, in the opinion of Webb, who has studied and described much of the fossil material recovered from the Atlantic Lakes region, the distinct morphology of some Australian fossils cannot have an origin anywhere else other than Indonesia. It is not something developed within Australia, an aberration of the Ice Age, nor can it be one end of a wide range of anatomically modern human morphology that came out of Africa. Indeed, it was precisely that anatomically modern humans were not cranially robust that distinguishes them as such. Whatever the genetic evidence suggests, the only people around who convey such an outstanding morphology must have been Homo soloensis or its descendants. There is no other upper Pleistocene population from whom such a heavily built cranial structure could be inherited. I'm not the first to invoke the Indonesian connection among Australian fossil hominids. Note that Homo soloensis is used by someone referring to the Nangdong Homo erectus series crania. According to Josephine Flood, and WH50 is massive. He is so robust, he makes Cow Swamp Man look gracile. Cow Swamp is another sort of robust type human found in Australia. The cranium is extremely wide and approximately 210 millimeters long. The cranial wall bone averages 16 millimeters thick. Massive brow ridges form a continuous torus above the eyes, and the forehead is flat and receding. The back of the skull shows even more archaic characteristics with substantial cranial buttressing. The neck muscles area is huge. The skull is extremely wide. The greatest occurs very low in back view, and the difference between the width above and below the ears is much greater than in any modern people. Yet WH50's brain was extremely large. Its estimated cranial volume is 1540 millimeters, well above the average 300 for modern skulls. So that's in a quote. The cranial capacity of WH50 estimated about 1540 cubic centimeters would most likely have resulted in its arbitrary exclusion from Homo erectus, no matter where it had been found, as occurred in early discussed crania, such as Suzhou from crania from China, about 1,800 cubic centimeters. However, the issue is not with attributing WH50 to Homo sapiens, which is what it is. Here shows another Homo erectus Sangerian 17 cranium from Sangerian Java, Indonesia, about 1,000 cubic centimeters is estimated cranial capacity, allegedly dated about 1.25 million years ago. Now, according to Wolfbuff and Lee, the similarities that WH50 and certain other Australian fossils have in Nangdong include aspects of the Nangdong remains that Kafer and Collex consider unusual or unique in the region. This supports the contention that Australians have some of their ancestry from these Indonesians or a population similar to them. At the very least, these resemblances create a phylogenetically ambiguous situation. Unless one is willing to consider the possibility that all of these samples of early to late Pleistocene Homo are in the species Homo sapiens, the description that Nangdong remains above Homo erectus from the demonstration of similarities to Sangerian and Homo sapiens from the demonstration that Nangdong is one of the ancestors of WH50 and other Australians defines a lineage that's a difficult name because no evidence places fossil Australians in Homo erectus. Instead, every modern scientist who is familiar with the Australian fossil record agrees that by virtue of all of their anatomy and the time, place, and cultural association where they found, every Australian fossil now known is uniquely Homo sapiens. As already indicated, the issue is not with attributing WH50 to Homo sapiens, which is what it is. Rather, the problem is caused by not seeing Nangdong Homo erectus individuals as also Homo sapiens and hence descendants of Adam and Eve. It is also interesting that the Nangdong Homo erectus individuals are considered as candidate Denisovans by some evolutionists, as are the Dali, Suzhou, Harbin, and Genus specimen from China. In their extensive review, Peregrine et al. Reported that evidence gathered on the Denisovans to date include a history of numerous episodes of interbreeding with Neanderthals, as well as the modern humans and possibly other ancient human groups. In a similar manner to it not making sense to view the Neanderthals like WH50 and Nangdong individuals as separate species, nor would it make sense to view some Homo erectus specimen, for example, Nangdong, as human, whilst viewing others, for example, to suppose the early Suggerance specimen, which is supposed to show similarities to, as subhuman. All Homo erectus specimens should be considered as belonging to Homo sapiens and hence to be descendants of Adam and Eve. Now, this shows you a Damenese Homo erectus specimen D344 and D3900, the referring to the cranium and the jaw, lower jaw. Now, the individual experienced extensive tooth loss and reabsorption of tooth sockets of both the maxilla and mandible before death, as you can see in the diagram there. Now, this Homo erectus specimen from the Republic of Georgia is said to have had advanced alveolar bone atrophy, indicating substantial tooth loss several years before death as a result of aging and or pathology. And according to Lord Capinzi et al., I quote, the D344/D3900 individual survived for a lengthy period without consuming foods that required heavy chewing, possibly by eating soft plant and animal foods, and by virtue of help from other individuals with much of the exceed capable of being offered by non-human primates, unquote. This is strong suggestive evidence indicating Homo erectus population cared for the infirm among them. Okay, so that's where I'll kind of end my presentation, Brian.
All right. I have before I get too much into that, I was wondering, I'm not sure, I don't remember you mentioning anything about Homo florensis, the one that they called the Hobbit.
Well, it kind of it was sort of about Homo, is about, I guess, human origin. So because of time, if I discuss a Hobbit, it'll take a long time,
Right.
because I believe that was a pathological specimen, likely a pathological Denisovan, and if the Denisovan were like Homo erectus and Heidelbergensis, so it's a pathological robust human in my opinion. Some evolutionists believed it was a pathological modern human, but that conveniently redated to a time where it was, in their view, no modern humans were in that area. So I don't hear about the pathology hypothesis anymore conveniently. But yeah, no, there's just not time to discuss everything. So I have discussed it elsewhere, but not. Yeah, I haven't. There's just not time for
In
that.
terms
Yeah.
of the differences in Homo, for instance, the Hobbit, could you explain what you think is the responsible for the height difference? Because that's the reason why a lot of people refer to it as the Hobbit, is because obviously it's much shorter. Um, some people have suggested allendorphinism. I think you suggested something on standing for truth. Um,
Well, I think, yeah, I cover it in a lot of detail there. I do. I find that the correctness of hypothesis suggested by evolutionist Charles Oxnard, who's an expert in anatomy, is very, very relevant. But I believe it's because it has features that seem more robust or similar to some of the Erectus specimens. It may be a pathological Erectus, and whatever, or a robust human type. And cretinism can produce extreme dwarfism, and a lot of things that kind of mimic it. According to Charles Oxnard, I haven't got the quote here, but it's sort of a lot of the features in cretinism mimic the so-called primitive features in evolution. So you can get sort of brain reduction, large feet, and things like that. I talk about it more in that presentation. But it explains a lot of the morphology. It was not an ape by any stretch of the imagination. So,
Right, you could
but
say it was
it's probably
vegan
different.
human. I mean, just no different than, like, say, a dwarf today or something like that. Just has some kind of feature.
Well, it depends on what sort of dwarf you're talking about, because it sort of had a very small head. I'm not an expert on dwarfism, so it sort of depends on what sort of dwarfism you talk today. Now there are several theories proposed on evolution as to explain it. Some say microcephaly and sort of all sorts of things, but yeah, the reason I prefer cretinism, and I believe some specimens like Homo naledi, even some of the Demonesian skulls, like the skull 5, which is strange, but cretinism, because in some of the areas they're kind of highlighted as goiter areas, and in goiter areas with lack of iodine in the food chain, you get cretinism. And cretinism also, you don't have to wait for excited and genomes for these things to appear. It's a environmental thing, so it can occur in any when if generation is exposed to low iron deficiency in the offspring, you can have goiter, or if during certain stages of prenatal development, if it occurs, you can get cretinism where the kind of thyroid gland is dysfunctional when at birth. And so today you have supplements you can give thyroid hormone tablets to basically make it for the lack of production of thyroid hormone in the body. So I remember giving my dog thyroid tablets, things like that. So
You
yeah.
mentioned Homo naledi just now. Would you say Homo naledi is human? I know they put the word homo, but as you pointed out, just because they
Yeah,
put the word homo doesn't necessarily
yeah,
mean.
yeah.
But
Well,
Homo naledi, would you say that that's
yeah,
human?
yeah, absolutely. I think it's a sort of it's basically to me it's Homo erectus, but there are some strange features in a lot of the postcranial anatomy, which indicates so some are, because I can't generalize all, because there may not be all of them, but a few of them, some indicate there was extreme dwarfism, and some of them by the size of the the centrum of the sacrum. There, very, I think it has the tiniest, or the area of the sacrum, um, the top of it was, I think, smallest in fossil record or something like that. So that indicates extreme dwarfism in some specimen, but not all. And some of them had, kind of the the shoulder joint was really sort of, and humeral torsion, the twisting of the elbow, the kind of the elbow respect to the shoulder joint, this humerus was kind of really really different, and it's suggesting some sort of pathological development. And there's a lot of features. Um, some of the features haven't can be confirmed. Like I say, they had a really funnel web, like a Lucy-like rib cage. That's seen in cretinism, and in dwarfed individuals. So there's a lot of funny features there. Again, standing for truth, I gave a really long presentation on it.
Yeah.
So probably. But yeah, the thing with it is, though, it it walked from its feet, that and legs, it walked pretty much. It would have walked like a human. So if people are saying it's not a human, well, then I know that a lot of people, the thing is, then you're basically saying an ape walked like a human. That's what you're saying, because its feet were, the medial longitudinal arch. It had the big toe in line with the other toes. It had the longer lower limb bones. So it walked like it had the features. It walked like, from some of the bones that indicated it walked like a human, and so that's, so to me that's where that's why it's important to look at the whole thing, not just look at the skull. You've got to look at the whole thing, and and take everything into account. And 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 the logical thing is, that it was like your Homo erectus, but some of them had some pathological features. I don't know what all of them have. I don't know why they were in their begin with. I mean, there's been a lot of controversy now over because the Berger team found that published stuff that the first evidence that they used fire, that they buried their dead, that they made engravings on the walls. And so this, I know there's been a lot of opposition to this. I'm not surprised at the opposition because that's what happens when you, because of it would pretty much overturn everything about recent modern human evolution for evolutionists. So that would turn everything on its head. So there's a real big fight. There's a big sort of there's a big sort of pushback against it. But the thing is that the pushback based more on, oh no, we can't have this, rather than on the evidence itself in many ways. So
Right.
I'll look at the evidence. I don't care what their philosophy is. I'll look at the evidence,
Right.
and the detractors haven't really come up with strong evidence. So certainly, I think there's a good, to me, there seems to be fire and burial. The engravings, I'm not 100% sure, but we'll wait and see how this develops. But there was so they published initially, then there was a response by the detractors, then they republished it on the burials, and I don't know whether it's gone through peer review yet, so we'll see what happens. But it's all very interesting. But
Right.
I believe they were human, yeah.
Okay, good.
But there was some pathology there, and likely due to cretinism again, because that was sitting on next to a goiter area. I checked in the map. It's sitting on a goiter area, just like the Dmanisi region is in the Caucasus is a goiter area, and Charles Oxnard as I got the Hobbit, where the Hobbits found that there was likely goiter there too, and cretinism. So all these areas have a history of sort of this sort of stuff, as far as I know, or at least for goiter. And to get cretinism, you have to have iron deficiency, and goiter is an indication of that. There could be other pathology, but I'm just thinking that the most easiest one to explain is one that you don't need fixation time for mutation to move through populations, because that will take you a long while.
Right.
So that's why I think an environmental explanation is more logical, but I may be wrong. Who knows? We'll see.
So you would say that there's strong evidence not only of bipedalism, but also that it is human bipedalism. So it's a very important distinction right there.
Yeah,
That means they walked
yeah,
and moved like we do.
yeah. Well, I think the sort of their limb bones and their feet, it indicates that they would have pretty much walked like humans,
Right.
That sort of they're not like the Australopithecines or anything like that.
There is
So
some.
that's
Go
yeah.
ahead. Well, I was going to say
No.
there is some controversy with the skull. I believe you brought it up to me before as well, or talked to me before. You said it was a little bit bigger than the Australopithecines, so some people think that it's like the same size as the Australopithecines skulls were, as it was it a little bit.
Well, yeah. I mean, there is some of the Australopithecine crania are probably likely inflated for starters. That even as Carl Werner has discussed some of the stuff, and even I published on it before in the book with J. Bergman, it's a lot of the Homo habilis stuff is inflated, but there's some of this cranial capacity is small in the Homo naledi, and that could be explained by cretinism because it can reduce brain size by up to 50%. So if you have a small Homo erectus individual has cretinism, that would explain it.
Well, we all,
The thing is that people shouldn't be. I have them presented it, but the thing is, people should realize there are also humans today with small brains, and there has been apes with larger brains than humans. So they found one gorilla with a brain size of 752 cubic centimeters. So that doesn't make it humans, you know, because if you have a lower brain than that, does that make you an ape? No, it doesn't. There's two factors you got to look at: organization in the brain, but also from a Christian point of view, what makes you human is also you have a soul or mind, a human soul or mind, and an ape will never have that. It doesn't matter how big its brain is. So you have to look at that, but that's the mind is not physical, and that's where you get into dualism and things like that. But you have to look at that aspect of us as well. That's what makes us human. We have a human mind or soul, whatever you want to call it, and that doesn't matter what the brain size is. The thing is, as I didn't give a talk, but I showed up. You can remove half a hemisphere in your brain, particularly when you're young. They do that if you have intractable epilepsy, where they remove it so the person can live a relatively normal life, and their brain functions take it. They were lost in one hemisphere, they move across to the other hemisphere. So in the end, it takes a while, but the person has a normal intelligence, and motor functions get taken over by the other hemisphere, which is quite remarkable. And so basically, there's a lot of plasticity in the human brain. But how do you explain that? How could you possibly survive? On the African savannah, where with evolution, say we evolved. How do you explain that humans have the ability to lose half a hemisphere and still live? Because in environment, evolution, adaptiveness, there was no half-brain humans to work on. If you got intractable epilepsy, you'd be dead. There's no one would do brain surgery there. There'd be no selection for it. How do you explain? You can remove half a brain and the person can still survive. That's amazing. But it also shows you can remove nearly half the brain or half the hemisphere, or you can't remove the brain stem and part of the diencephalon, or maybe small bits of it, but you need them to survive basically. But you can remove half the hemisphere. That means you can and still have normal intelligence. So what does tell you about the importance of brain size? Because then you got that would give you a small Homo erectus brain, and people have normal intellect. They go to uni with that. So there's basically, it shows. And there was one guy, Daniel Lyon, that had a brain size, and depending on how you measure, cranial capacity of 660 or 690 or something cubic centimeters. So that's in the small end of the Homo erectus range, and he was normal intellect, a human. He lived about 100 or so years ago. So again, they did an autopsy, measure these brain size and weight, and calculate it from there. So the humans with really small brains too. That doesn't make them non-human or ape. So it's all. And the thing is, it's the proposed. As I would have shown, but there's no. You got to also have selection value for if a brain size evolved over these millions of years, there has to be selection value for a larger brain size. But what's the selection? There's no real selection value for it, and the increments would be about a few pinheads of brain tissue per generation. There's no selection value in that whatsoever. So how could you possibly evolve? But there is cost developing a larger brain in terms of, because it uses a lot more proportional, more of the body's energy in terms of metabolism. But there's no real selection. But they say intelligence for what? What to survive in a savannah? You're not doing sort of calculus equations or designing rockets. You're just surviving. So if you can have a normal intellect today with half a brain, why would you sort of use up all your energy supposedly developing a larger brain for what? There wouldn't be much advantage to it. There's no selecting value in it, and that's the other problem with it. And but the problem is, evolutionists give you all this just so stories on the surface. The brain evolved this and that and all these features, but the thing is, they don't look under the hood. Explain the mechanics of it. Tell me how this happened. Tell me. That's the thing. They can't explain the mechanics of it, except making up more just so stories. Because if you look under the hood, a lot of the biochemistry, the nano molecules or systems, they're kind of reducibly complex. You're getting it, and the systems like the hormonal systems we talked a little bit about, all these systems, and the receptor, the neurotransmitters in the brain, and all this stuff. It's a horrendously complex thing, and there's trillions of connections in the brain. There's about 100 billion neurons, maybe 85, actually 6 billion is the latest count, but that may change. The thing is, how to suggest that somehow brainless bacteria created this for what? It doesn't have a brain to create it. There's no plan or intelligence. And just these systems that have feedback. If your hormone too much of this hormone, it gives feedback to the hypothalamus, tells it reduce the level, and all these the feedback system involves molecules themselves, the transmitters, the receptors, all horrendously complex. The waiting time for, say, one receptor, all the units on it. I mean, how long does it say you had 400 subunits, or 400 amino acids in one of the proteins of the receptors? How long does that take to form? What's the waiting time for that? That could probably take longer than the universe just for one. So these are problems I don't consider. They just wave the magic wand, evolution does this and that. But to me, that's not sufficient. You got to show it's plausible, and it's not. Only this intelligent design could ever create the human brain.
Right.
And I gave a talk on human brain outstanding for truth for a 2-part series. So if people want to listen to that, they don't need
Absolutely. All right. On the morphological differences, you gave a number of reasons why the morphological differences are there. Um, do you think adaptation could also affect some of these differences, like adapting to cold weather? Because, like the Neanderthals, for example, are believed to have lived in really, really cold climates. And I've heard that the larger nose would actually warm the air going into their lungs. Do you know anything about that? Like certain features being, and even the broadness. I think you mentioned that would also help if they live very long lives. That robustness would actually help with that. Could you explain that a little bit, whether you think the adaptation would also be a key feature that also could help their, be the reason for their differences?
Yeah. I think the Neanderthals are, you kind of read conflicting stories about the studies that shows some say that they whether they cold adapted, the big nose was the, yeah, I don't know, humidify or warm the air. I don't know. So it's hard to say exactly what that was, but they were kind of more stockier built, more solidly built, and Eskimos sort of built, which means sort of preserving bodies, which means if you're not lean and tall, shorter and more stocky or more solid, then basically you'll preserve body heat better, and that would be good for living in cold conditions. So they may have adapted to that, just from the, so that may be an environmental effect. We're not sure what effect of any of that on genetics. It may be an environmental effect, and whether there's any epigenetics in that, I don't know. As for the robusticity, longevity, what I guess when I thought about it a few years ago, I was trying to figure out what is there a reason for it. I mean, God, when you in one way, when you think about it, God doesn't need a reason to create variability. If you look at all the different butterflies and beetles and all, or look at different dogs and cats and all the things. So variability, God has made great imagination and things like that. So he doesn't really need an explanation. It could be, I don't know what in his mind. It'd be a boring world if we all looked identical.
Yeah.
And so yes, God doesn't need to create variability, and it would be a very boring world if we all looked the same, like if we were all like identical twins.
Yeah.
So in that reason, but I guess I was trying to thinking about, what could explain it. Is there a reason why, and when I say robusticity, it doesn't have to mean the extremes of the extreme brow ridges, all the extreme features. It just means you're built a bit stronger. You have thicker wall bones in the skull. It means more moderate features, because extreme features can be recorded by having two of the same genes for that particular thing or whatever. So it's more moderate, but like and my thinking is, if you live, say, in a prefab world 900 years, if your body today would not last that. In the 40s, you start to lose bone mass, certainly postcranially. So, if I had a choice, being built like a stick insect or built like a rhino, I'd rather be built like a rhino if it's going to live 900 years, because my body would basically be much stronger, and I wouldn't be that affected by bone loss as much. So that's my thinking, that you're built more strongly because you're living much longer, but something had to be physiologically different. You couldn't lose bone at this current rate because your body's shot at 100. It's not really going to. So something was different about them there. And usually if something different, it wouldn't be. Jack Corso years ago proposed it was the aging process in Neanderthals, but I don't think. I think it's more the development, maybe that slow maturation, but it doesn't have to be slow maturation. They could just be developed differently. Like, that's why I put those things up about different intensity of hormone production during development. That's how you change it. That affect bone growth. So you can build your stronger, thicker bones and stuff like that just by changing the levels of hormone production and when it's produced and things like that. And so I don't know what happened, but certainly our bodies now cannot survive for hundreds of years, and so I think something had to be different. And so why couldn't that also be that we were built stronger? That would make sense. And we also don't know what was the environmental conditions in that pre-flood world. Whether being built stronger also helped in that, and then it reduced that. In post-flood world, it still did long for a few centuries after, but it was certainly reduced. So that was the way of trying to some sort of explanation for it. But look, in the end, it may be wrong. I don't know. It may be just God creates with variability and the potential for variability and things like that. So it's still an area that needs further work and research. But I guess if you don't put suggestions out there, no one will come up with nothing. So if someone has better ideas, then that'd be great.
How much does inbreeding play in this? I know in Neanderthals, there's strong evidence of a lot of inbreeding going on. So, how much do you think inbreeding? I think you mentioned something about inbreeding also, maybe with Erectus, maybe. I can't remember which one it was that had inbreeding in it.
Yeah, I think a lot of that, the end stage of them, like say you have people with this robust morphology moving out of Babel, they take different subsets of genes with them. They may have genes for robusticity that might vary slightly, and then you have inbreeding where that because they're kind of a small group, and eventually they kind of have two copies of the same genes. So it means that the features will become more pronounced. So if you have more moderate brow ridges, may become more prominent if you have two of the same genes for it, producing that. So that's my thing about the inbreeding. I don't. And look, they can cause also. We know today it can cause pathology, but this was early on, early post flood, and the gene was more intact. Gene pool was more intact too. So yeah, the inbreeding and so, but I don't believe, for example, that one theory is that modern humans radiate out independently and turn into sort of Neanderthals and then Erectus independently by inbreeding or mutations. That to me that's theoretically impossible because it involves waiting times for mutation to fix, and that takes a long time, and that for it to happen similarly in different places in the world independently, that's like the multi-regional thing. It becomes untenable genetically because it's too much of a coincidence. You wouldn't so the thing is you do have pathological Neanderthals Erectus but they still remain Neanderthals and Erectus, or let's call them robust humans, because I believe they're all kind of the same, and they're just different versions of the same. Just so you have pathological robust humans, but they still remain robust humans. They still, sturdy people built and things like that. But yeah.
What would you think is cause of the brow ridge? You mentioned stuff that can actually affect bone growth. I think something about thyroid as well.
Yeah. Well, I think a lot of if all the bones are fused and in this area, then it'll just grow outwards. So that's the theory about like when you have acromegaly or whatever, that sort of excess bone growth after the bones have kind of fused and it can't go longer or more, and the membrane is bones are fused and things like that. So then it'll grow outward. Look, I'm not 100% sure what actually would cause that. I was just suggesting possibilities that you have these if you have a lot of excess growth hormone, then that could cause it, and particularly depending on what's happened, you know, you can't rule out that in some specimen there was some pathology. There is pathology in modern humans too. But certainly, and maybe that's what I'm saying. If you have two copies of the same genes in certain individuals from inbreeding, that could produce really pronounced ones. But the moderate ones, I don't. That it may just be a feature of variation.
Right.
You know.
And you got like if you go on Oriental, they've got like these folds over their eyelids that they actually help redirect the sunlight over their
Yeah.
eyes. So I don't know if it was something like that, if it's something that would have been
Yeah.
useful for them in their current environments. Um, my understanding is that there are
Yeah.
Neanderthals.
There's also there's also the expect.
Go ahead.
No, there's also evolutionists have all sorts of explanations, but there's no definite hypothesis on it. So I don't want to say I know exactly. I don't know exactly why or how or whatever, because it's just be another. It's just speculation, really. No one knows why, and it's sort of similar to the chin as well. Why some don't have a chin and why some don't. We just don't know. There's some things you just don't know. Um,
Um, on the Neanderthals, they have you said they had what to call it? What's it called? Occipital bun.
Occipital bun
Yeah.
is just like a bun shape produced in the back. Some of them, at least. Not, I don't know if all of them have it. Most of them have it. But again, there's just a variation, a little bit of variation in skull shape. There's no big deal. It's just the thing is, for starters, we already know that they interbred with humans, so that already makes them human. So it's already part of humanity.
Right.
So we know this variability exists. That's the thing. And you find variability, and you can see the Land Lakes hominid 50 that I was talking about. Everyone recognized that as a modern human, Homo sapiens, and that has Homo erectus features, but it had a brain larger than the average modern human.
Doctor.
So it's sort of this is so sort of people people make too much out of features. Like I said, the phrenology of the 19th century, where you would class as that classified your mental abilities or criminality based on humps and bumps on your skull. That was just a fraud. Or it was totally wrong. And sort of, you know, so people today classifying humans as different species, again, based on humps and bumps on the skull. And people got to be careful about that because there's so much variability in existing humans as well.
Right.
That sort of is this sort of um, can lead to it's not very good, and it's all based on the theory of evolution. It's only because they have to have it for their theory. Otherwise, yeah. So to me, it's not a big deal. You
Dr.
know,
Jerry Bergman says that there are Neanderthal features in modern humans. Would you say that I know that there's evidence of modern humans and Neanderthals interbreeding in the past. Do you think that there are some features that are kind of showing in modern humans because of the genetic of some of the genetics being that of Neanderthals?
Well, the thing is, the problem is when you get a dog, you only see the average modern human skull. That's the problem. So you don't get to see the more different ones, you know. So not everyone has a vertical forehead, a big brain case. So you can, if you know, and some have brow ridges. Us, you know, so you see features, but they're not as prominent, you know, and that's the thing. Yeah, yeah. So yeah, it just sort of th 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 there's a lot of variability in humans, but you don't see it as much as probably you see it in a fossil record. That's why I believe that early humans were kind of built more robustly for whatever reason. Well, a lot of them were, and you don't see that as much as today, but you do see it. But it always it's always the sort of the anatomically modern human skull that it's compared to, but it don't they don't pick out the ones that aren't so modern, and there are some that aren't so modern, so-called modern.
Right.
And what is modern is just whatever some people say is modern, but you know that just conveys that some
And
yeah
the modern human,
yeah I just yeah I don't
right?
know.
And what they call modern humans is actually being found with Neanderthals. If I'm not mistaken, have they found them in the same grave sites? Modern humans and Neanderthals?
Well, well, they certainly, yeah. Well, a lot in Europe, they overlap in Europe, and they are, and certainly, supposedly modern humans now they believe they rose around 300,000 years ago. It used to be 200,000 years in Africa, and they migrated out 100,000 years ago, replaced all the archaics and Neanderthals. But now they're finding everywhere that they interbred with the local people. So because they're finding characteristics of it in the fossils that as opposed to modern humans, there were characteristics that were from the robusts or archaics or whatever you want to call them. So they're, I don't know if they found them in the same grave. I can't say that, but they're certainly they occupied parts of Europe, even in the evolutionary theories. They was in Europe at the same time, at least for a few thousand years in the evolutionary theory. So yeah, to me, the Neanderthal is really it's really not a it's a non-issue. They had large brains as us or larger. It's just they were adapted to probably living in a cold in extreme environments. They would probably do better than any of us if we had to live in those environments. Imagine us going and living in Ice Age Europe.
I would
That would
laugh.
be pretty tough, you know. So um,
Right.
you know,
Um, uh, I got a few more questions left, but the burying their dead, that would also suggest a kind of a moral center to them, right? Because I mean, animals typically don't really
yeah,
bury their dead. They
yeah,
might bury a bone or something.
that indicates that. Uh, Yeah, yeah. Only as far as I know, humans kind of go out of the way to bury the dead in a ritual manner like that. You know, so that would be indicator of humanity. Yeah, yeah,
Uh,
definitely.
Um, all right. I was going to ask, how much
Yeah.
do you think interpretation plays into looking at the fossils? Do you think that interpretation is a big deal as far as how they're looking at it and how they're approaching it?
Oh, well, interpretation is pretty much everything. The the as one evolutionist said, bones are fickle. I'll sing any song you want. Uh, I don't know. I think it was. I won't, I think it was. I don't, I'm not 100% sure of the author of it, whether it was Shreve or someone like that, but um, that they'll sing whatever song you want. So interpretation is everything. That people have to realize that
Right.
that that
You've been
people can
studying this
interpret
subject.
anything.
You've been
And
studying this subject for years. What is your conclusion after all the study of the hominin fossils? Do you think it proves evolution? Do you think it proves, well, more creation than evolution? I mean, how do you, as a creationist, when you look at this evidence, how do you how what is your conclusion as far as how you understand, that maybe this is not something that creationists should freak out over or something like that, because evolutionists think that this somehow supports some sort of evolutionary development.
yeah. Oh, look, I don't think it supports evolution at all. I think a lot of the a lot of it's showing, because a lot of the fossils coming out, they're kind of more um, Australopithecine types, and they're grasping at straws to try to make them like or the dates to try to make it like an ape man. But realistically, you have the Australopithecines in Africa were extinct apish primates. That's what I call them. They may not have been like apes today, but they were extinct apish primates. And what you find is you find some variation in it. Whether they were, but they may have still been just one biblical kind with a lot of variation, as you see today with cats and things like that. So so it may well have been something like that, and that's what you see. And then you see robust humans, and you see maybe some pathology in some of the, like, Naledi, Damaneasy, Hobbit, some events, but you see pathology in modern humans too. So, but you see some of robust humans, but you don't see anything really in between them. That's what you don't see. And and the, and the, and we don't have all the answers, but the thing is, you you see all the dates change, and the Hobbit thing was one of them that conveniently changed. When people were saying was a pathological modern human, it was conveniently they found another date that was older, so to rule that out, it was nearly ruled out. So that smacks of something, that these people, they look. I admit I'm biased, but don't tell me that they're not biased. They're totally 100% biased evolution. You if they're not biased, then they go out and I'm sure they can find some evidence for intelligent design and speak it and say it and see how long they'll keep their job. That's the thing. It's a, evolution is in academia is a gravy train, and the people have to, if they want to keep their jobs or work, they have to kind of follow it. I never followed it, but you have to be smart, keep your head low. It's unfortunate. It shouldn't be like that. But when you think about it, the only alternate explanation is kind of omitted from academia. What kind of a world is that? What is that, a search for truth, or that just search for an ideology, regardless of the truth? And that's what we got academia, where everything is geared to support that. There is no fair play. People got to realize that, and all I would, and it's not sort of the evidence that you see, but it's often the evidence you don't see, like the dates you don't hear about, because they record all these dates of things. What about the dates they don't report, they don't get to the literature? That's what I'd like to know, of all these fossils, all the contradictions, all this stuff. That's what you like to see. So there's a
Yeah.
lot of
When they when
yeah.
they dated,
So yeah, I did the I what I got into is that I hate for anyone to reject God because I think we're from ape man. That's one of the reasons I got into this, because it it's just so untrue, and it can't even be true, because I'm actually a brain scientist. You study the brain, that organ did not create itself. That that was divine intelligence, and don't even start talking about the mind. We don't even know what it is. It's not physical. How could that evolve if it's not even physical? But even the physical brain is so almost infinitely in functional complexity, and we're talking about a few bones and bumps on bones, and people get so worked up about that. But that's just nothing. That is absolutely nothing. And people, yeah, people should not reject the Creator God because they see some bones that are falsely interpreted by some to be ape men. The interpretation come and go, but evolutionists will always interpret it according to evolution because that's the nature of the game they play.
Right.
And that's why we try to put a different perspective on it. But we don't have access to we don't have the benefits they have of access to the fossils and all this stuff and all the media propaganda. But in the end, the truth comes out. The truth sets you free. So
Right.
someone said
Um,
that once.
yeah, what a lot of people don't understand is that a lot of people times no one has access to the fossils. They don't let
Yeah,
nobody see
yeah,
them or nothing. A lot of times they even put
yeah,
the
yeah.
cast out on display, and it's not even the real fossil because they're so
Yeah, yeah,
afraid of.
and you see casts of them, and you don't know whether they've been reconstructed accurately either.
Right.
I got some doubts, even some of the fossils that you see that the some of the when only part of the face is sticking, you can make it twist out that way, you know, to make it more open. There's a lot of things we just don't have access to. We know, and the thing is, evolutionists are just as religious as Christians are, even more so. They you know in
If we
some
get,
ways because there's no reward at the end of it. It's just the best I can hope for is oblivion, but sadly that's not going to be the case. You live forever. But there's two places you go after you die. You have you have two. There's two alternatives, and if you don't, if you if your life, if Jesus Christ, the only begotten Son of God, was not in your life, and you didn't believe He was there in His resurrection from the dead, that He died on the cross for your sins, and that He is Lord. If you don't believe that, then you're going to go to hell. That's the sad reality, but that's reality. And if I didn't say that, then I'd be a liar. And then there's sometimes things are uncomfortable, but that's the thing. If it didn't matter, there wouldn't be any point in doing this. But the truth does matter, and it has eternal consequences. And that's the reason why I'm doing it. Otherwise, I could do better things, other things. But it's still the same. It's very interesting. I find the subject very interesting. So it is stimulating. I don't mind controversy so much. Um, there's a lot of grey areas in science. Not
yeah.
just this area. There's a lot of other grey areas. Yeah.
On Naledi, I was going to say that when they dated Naledi, it didn't fit in with their chronology of what they think humans were, and so they started looking at the Earth or the ground that it was found in, so it's like they're picking and choosing what like this date doesn't work, so we're gonna go and try the here and
It was actually they thought it would be closer to 2 million years. Then the date was 230,000 years, although the carbon dating showed it was about 30 odd thousand years. So they rejected that. So that shows you a lot of variability. And then now Naledi is very hard to fit into an evolutionary scheme. So some have even proposed that it was had some evolutionary reversals. It became more human-like than where I talk about it has some strange features in the postcranial year, particularly postcranial year. Some of them were evolutionary reversals. They were going back to becoming more apish.
all right.
So that's mental gymnastics because you can't explain something.
Thank you again, Dr.
Okay,
Line. We appreciate your time. I know it's been a long one. You gave a
that's
really
okay.
presentation. It's been fun. I enjoyed it. I expected a long ride, and that's what we got. So I
Yeah.
appreciate it. I'm actually going to be
Probably
interviewing.
too. Probably.
I was going to say I was going to
Probably
interview.
too.
I will be interviewing Dr. Andrew Snelling next month, and he's actually moved back to
Okay.
Australia, so he lives in your
Okay.
neighborhood, or at least in
Yeah.
Australia. Um, but anyway, thank you again, Dr. Line. We really appreciate it very much.
My pleasure, and God bless you and your ministry, and I'm sure we'll talk again in the future.
And thanks, yeah, and thanks. Sorry for the technical difficulties that we had. I know we had some
That
technical
happens to all.
difficulties It
That
just,
was always.
yeah, I'm sorry about that, but it does happen. I see usually don't do live interviews because of my
Yeah,
internet.
yeah,
But anyway,
yeah.
I guess this is all for now, everybody. Thanks for tuning in
Yep.
to Next 101. Again, thank you again, Dr. Peter Line, for your time and that presentation. That was really good.
All right. Thanks, Brian.
All right.
See ya. Take care.
God bless.
God bless.
Thank you for tuning in to Apologetics 101. And sorry again for the technical difficulties. I know that we were going to do a live interview with Dr. Peter Line, but that didn't happen because of all the super um, unstableness of my internet connection at the time, and it just went really bad. And so we had to do it by Zoom and not live. That's why I normally don't do live interviews because my internet's unpredictable. Things went okay with Jennifer Niza, but it might be good not to try to push the internet with presentations and things like that online if I can help it. So if it's just a straight interview, maybe like the way I did with Jennifer Niza, I could probably pull it off a lot easier. Um, but anyway, it was still, we managed to, despite all our technical difficulties that we had, we still managed to get it pulled off. We still managed to get together a great video. Sorry for the longness of the video. Most of that was because of Dr. Lyon's presentation. It couldn't be helped. It was very comprehensive presentation that he brought us, and and it was really good. I really liked it. I hope y'all stuck it out to the end. I know that was a lot of information to throw at everybody. So, but it was really cool to learn about that stuff. Wouldn't mind having Dr. Peter Line on again. We talked about, morphological differences. We talked about Neanderthals, Erectus, Naledi. We talked about Homo florensis, or what they call the Hobbit. We talked about all that. We talked about the differences and all the possibilities that could result in those morphological differences. Dr. Lyon did touch a little bit on the what evolutionists refer to as the out of Africa theory, the idea that all humanity came from Africa, and he dealt with some responses there as well. I may sit there and see if Dr. Lyon would later want to do a full video on just the out of Africa theory, where he can kind of elaborate a little bit more and go into more detail. I wouldn't mind seeing if he would be able to do that for my Are We Apes series. Thank you for tuning in to this particular episode on human origins, on all the, and zeroing in on the morphological differences and things like that. I thought Dr. Peter Line brought a really comprehensive presentation. I looked at my questions and he answered most of them. So that made my job a little easy on the Q&A. I was able to pick the questions that maybe he didn't dealt with very much in his presentation, which wasn't that many questions because, at that point. But that's why most of the video is the presentation itself that Dr. Line brought. It was about a 2-hour presentation, so that's the reason why for the length of this particular video. But anyway, it was still good. I love it. It was a lot of substance involved, and I hope to see y'all again. And don't forget to subscribe to my channel if you're new here. We deal with apologetics in general, but we do defend biblical creation as well. And we do so from a presuppositional apologetic point of view. And obviously, we defend the reliability of Scripture as well. And so make sure you subscribe to my channel. Don't forget to hit the like button, give the video a thumbs up. That will help YouTube get this information out there to more people. And we wanted to get out there to as many people as possible. It also helps support my channel a little bit. And so that way other people can get a hold of this information as well. Don't forget to hit that notification bell. Don't forget to share it with others. And I will see you on the next one. And as always, stay in the know.